Hi, in this one-shot video of Binomial Theorem, we are going to quickly cover the 12 types of problems that JEE has asked. There has been a lot of modification in the syllabus, but despite that, it remains a very important topic. First, I will systematically go over the changes that have been done in the syllabus. Then we'll go and see what kind of topics are there, what have been exactly excluded, what impact will it have on questions. And in the third part, I will systematically go into those 12 problem types that JEE has asked, tell you the basic theory, the technique involved, and solve those problems to cover all the important questions that came in the last 3 years. So let us start with it. So let us start our discussion with the most important thing, that is syllabus changes that happened from 2023 to 2024. So if you look into the syllabus, the core parts, binomial theorem for positive integral index, general term, middle term, simple application, this part remains same. But there is a major exclusion in this chapter, and that is the properties of binomial coefficient have been removed. Now, it has a lot of consequence from problem solving point of view, because there was a very large part of this chapter that consisted of problems based on series. Now, after this exclusion, those problems cannot be asked. And that is the reason, while making this one shot video, I have kept those portions, those problem types out of the purview of this one shot video, because according to me, based on this modified syllabus, those questions cannot be asked. There will be a separate video on series based questions in binomial theorem. Once you are gone through all of these one shot videos, you can go over this video. In case there is a question based on that idea, then it can be covered after watching that video. So let us start with it. Now we start with the core areas of this chapter. It starts with a general discussion of binomial theorem. Then questions based on general term, that are term from beginning, term from end, middle term, independent term, rational terms. Some useful forms. Then some properties of binomial coefficient, which is now out of syllabus. Then summation of series part, which based because of the properties are now out of syllabus. And then some miscellaneous area like I plus F category problems, divisibility, approximation. And then application of multinomial theorem to solve questions based on multiplication of two binomial series. And usually we end this chapter with binomial theorem for negative indices and fraction indices. Now you can see that based on latest pattern, for JEE means point of view, a lot of these areas are not important. So I will only focus on those areas that are relevant. And in order to make your life very simple, I have divided this chapter into 11 relevant problem types. I am going to give you the basic theory that is required and quickly jump onto the problems based on 2019 to 2023 and show you how those problems can be solved using binomial theorem. So without further delay, let us start with it. So let us have a start our discussion with this concept of general term of a binomial expansion. So if you look into a binomial expansion, that is x plus y raised to the power n, the general term, that is the r plus 1. See, important part here is it is not the rth term, but r plus 1th term. What does that mean? If you want to write the 7th term, it is t 6 plus 1, and that would mean nc6, x raised to the power n minus 6 and y raised to the power 6. Now, this is very important, and I have seen a lot of students, despite knowing this, committing this mistake time and time again. So this is very important concept that you should remember, because using this, we are going to jump onto our first problem type, that is nothing but term from beginning. Now let us look into this question that came in 2023. The question is very simple. It talks about the coefficient of x raised to the power 5 in the expansion of 2x cube minus 1 by 3x square raised to the power 5. So in such kind of questions, when they are asking about coefficient of some power of x, the first step is to write the general term. So if I write tr plus 1 here, in this case, it is going to be 5cr 2x cube raised to the power n minus r, that is 5 minus r, and then minus 1 by 3x square, that is the y part raised to the power r. Now if you take all of these terms and simplify, what we are getting in coefficient part, see now here, and again one more thing is, this 5 here is binomial coefficient, but if I take 2 raised to the power something and 3 raised to the power something, it becomes the coefficient part. This difference you should understand as a student of mathematics. So this can be written as 2 raised to the power 5 minus r minus 1 by 3 raised to the power r, and on the power of x, now you can see that it is nothing but 15 minus 3r, and in the denominator it is nothing but x raised to the power 2r. So if I simplify further, it becomes 5cr 2 raised to the power 5 minus r minus 1 by 3 raised to the power r, and in the power of x, what we have got is nothing but 15 minus 5r. Now, the question talks about a term, and that term needs to have x raised to the power 5. So, whatever we have written in the power of x, that needs to be equal to 5. So, if I equate this, 15 minus 5r would be equal to 5. And if I simplify this, 5r is coming out to be equal to 10. So r becomes nothing but 2. Once you have got this, you can substitute in the third part these values in the original term and get the value of the coefficient. That is nothing but what our question says. So if I put those values, it becomes 5c to 2 raised to the power 3 minus 1 by 3 whole square. Now if I simplify this, this is nothing but 5 into 4 divided by 2. This becomes nothing but 8 and this becomes 1 by 3 square. And if I simplify this, you can clearly see that this 2 will get cancelled out. It will become 80 by 9. If I look into my option, my B option comes out to be correct. Now this next question came in 2023 and it talks about the same idea. Coefficient of x raised to the power 10 and x raised to the power 7 we need to find and subtract. But we have to do the same process twice. And in order to make things even more interesting, what we have got is 2x square plus 1 by 2x. So this 1 by 2x is coming in the question. That is something new. So in order to handle such kind of questions, it makes a lot of sense if I take LCM and write this numerator as 4x cube plus 1 by 2x. And in order to make things even more simpler, let us retain the power of 11. Also write this as 1 plus 4x cube by 2x raised to the power 11. And which can be even simplified and written as 1 plus 4x cube raised to the power 11 by 2 raised to the power 11 into x raised to the power 11. Now the interesting thing is, if I want to find the coefficient of x raised to the power 10 in this, the numerator should contribute x raised to the power 21, because out of that we'll subtract this x raised to the power 11 and we will get the answer for x raised to the power 10. Again, what I'm saying is, see, let us say that in my numerator I am able to generate x raised to the power 21. There is some coefficient here. Then this will get divided by 2 raised to the power 11 and x raised to the power 10, x raised to the power 11. And as a result, when you simplify, this coefficient will remain, 2 raised to the power 11 will come, and we'll get the coefficient of x raised to the power 10 after simplification. So the numerator that is here should now give us the value of x raised to the power 10 plus x raised to the power 11, that is x raised to the power 21. So in order to do this, now what we are saying is, this answer will be equivalent to coefficient of x raised to the power 21 in the expansion of 1 plus 4x cube by raised to the power 11 by 2 raised to the power 11. And if I want to do the same process for x raised to the power 7, for that what we want is x raised to the power 7 plus 11, and that is nothing but 18 in, so this we have to find in 1 plus 4x cube raised to the power 11 by 2 raised to the power 11. Now this is not very difficult to find, because the general term here can be written as nothing but 11cr 4 raised to the power r x raised to the power 3r. This is the general term. So if we want to find the coefficient of x raised to the power 21, the value of r should be nothing but 7, because 3r is equal to 21, r becomes 7. And from here we can find the coefficient, that will become 11c7 into 4 raised to the power 7 divided by 2 raised to the power 11, because this was already there. And similarly here, if I have to do, the corresponding value of r comes out to be, see here, 3r would be equal to 18, so r comes out to be 6. And here if I simplify, my coefficient comes out to be 11c6 and into 4 raised to the power 6, and we already have got 2 raised to the power 11 in denominator. So if you simplify this, out of this first part, I can take 4 raised to the power 6 by 2 raised to the power 11 common. So what I have left with is 11c7 into 4. And then from the other side, what we are left with is nothing but 11c6. If you simplify this, this comes out to be nothing but 12 into 11 into 13. Now let us check our option. If you check your option, the option C is the correct answer. Why? Because if you simplify this part, what you are getting from here also is, if you take 12 common, it will become 12 square minus 1. And this, if you simplify, can be written as 12 minus 1 into 12 plus 1, that is nothing but 12 into 11 into 13, which matches our answer. Now this 2023 question is based on similar kind of concept, but instead of giving one binomial coefficient, they are talking about two binomial coefficients here. So if I apply the similar technique, I can take LCM and write this as a b x raised to the power 3 minus 1 raised to the power 13 by b raised to the power 13 x raised to the power 26. What we want is nothing but coefficient of x raised to the power 7. So from AB x raised to the power 3, I am taking minus 1 outside, raised to the power 13 by b raised to the power 13. Out of this, now you can see that this power we need to add to this power. So what we want is coefficient of x raised to the power 33. Now from here, you can see that that value will come corresponding to nothing but r is equal to 11 if we write the general term, and becomes nothing but minus 13c11 into minus ab x raised to the power 3 raised to the power 11 by b raised to the power 13. So you can see that the coefficient that we are getting from here is nothing but 13c11 into ab raised to the power 11 by b raised to the power 13. This is the first part. Now I can do the similar kind of calculation for the second part. So what we want is the coefficient from, if I take LCM, AB x cube plus 1 raised to the power 13 by b raised to the power 13 x raised to the power 26. Out of this we want coefficient of x raised to the power minus 5. Or we can simplify and write 1 plus AB x raised to the power 3 raised to the power 13 by b raised to the power 13. Out of this, now what I have done is, you can same thing, this power and this power I will add and say that out of this what I want is coefficient of x raised to the power 21. And if I see that, it will come corresponding to nothing but 7. So, and that term will look something like this: 13c7 ab x raised to the power 3 raised to the power 7 by b raised to the power 30. So the coefficient comes out to be Now, if I compare these two coefficients, equate them because they have been given equal to. So, AB raised to the power 4 will become nothing but 13C7 by 13C11. You can simplify this and comes out to be equal to 22. Hence, our option A becomes correct. If I look into this next problem, it has two parts into it. The first part talks about the sum of coefficients of the first three terms. So let us take the first three terms. So the first term coefficient would be nothing but NC naught. The second term's coefficient would be nothing but minus 3 into NC1. The next would be minus 3 whole square NC2. So these are the sum of the coefficient of the first three terms. It is given as 376. Now what I can do is I can simplify this. The first term becomes n, the next becomes minus 3n. The next one becomes 9 into n minus 1 by 2 is equal to 376. If I simplify this, this comes out to be 9n square minus 9n minus 6n plus 2 is equal to 376 into 2. I have taken LCM for this 2. And if you simplify this, this becomes 9n square minus 15n plus 2 minus 2 into 376 equal to 0. And now further you simplify it, it becomes 9n square minus 15n minus 2 into 375 equal to 0. And now what I can do is I can divide this by 3. So this becomes 3n square minus 5n minus 2 into 125 equal to 0. And if I simplify it, it is 3n square minus 5n minus 250 equal to 0. Now if I solve this quadratic equation in order to get the value of n, it will become nothing but 5 plus minus root of b square minus 4a and then c by 2a. If you simplify this, see, we cannot take negative sign because then what will happen is the value of n becomes negative. If I take positive sign, the value of n comes out to be 10. Now once we have got this value, let us jump on to the next part of this problem. So next part of the problem talks about the x raised to the power 4 wala part. So if I write the general term, Now since the value of n is equal to 10, I can write the general term as 10 CR x raised to the power 10 minus r and minus 3 by x square raised to the power r. So if you simplify this, this comes out to be 10 CR minus 3 raised to the power r, x raised to the power 10 minus 3r. So what they're saying is, if you want the coefficient of x raised to the power 4, then this 10 minus 3r should be equal to 4. And that implies the value of r should be equal to 2. So once you have got the value of r, it is not very difficult to find the value of coefficient. That is nothing but 10c2 into minus 3 whole square. And if I simplify this, it comes out to be 40. So now let us try this next question. In this next question of 2023, what we can observe is they are talking about a term beta x raised to the power minus alpha. And in this term, this beta is such that it is a natural number and alpha is greater than 0. We want to figure out such smallest number that satisfies this logic. So now let us start with the general term in the first step. So I am writing the general term as 30 CR x raised to the power 2 by 3, 30 minus r, and 2 by x cube raised to the power r. And if I simplify this, this becomes 30 CR into x raised to the power 20 minus 2r by 3 minus 3r, and we will have a term of 2 raised to the power r also. So if I separate the coefficient part with the powers of x, we will get something like this: 20 minus 11r by 3. So this is what you are getting, and once you have got this, now the question is that whatever is in the power of x, that is nothing but minus alpha. So 20 minus 11r by 3, this is equal to minus alpha, or alpha can be written as 11r by 3 minus 20. If the condition that is given is alpha needs to be greater than 0. So we need to find such a value of alpha so that it is greater than 0, and obviously since r is a term, it needs to be a natural number. If I use both this logic, so what I get is the value of alpha, that was nothing but 11r by 3 minus 20. It needs to be greater than 0. So you can see from here, r needs to be greater than 60 by 11. Such number could only be, so this is nothing but greater than 5 point something. So the nearest or the smallest value of r that satisfies this is nothing but 6. And if I put r is equal to 6, corresponding to that, the value of alpha, let us see what it comes. So alpha comes out to be nothing but 11 into 6 by 3 minus 20, and this is nothing but 2. That becomes her answer. Now this very interesting question came in 2020. So generally in the questions that we are doing earlier, it was given that find the value of the coefficient of this term. Now here the question is in the reverse order. The coefficient is given and we have to find the value of m. So let us see how this works out. In the first step, we are going to write the general term, that is nothing but 22 CR x raised to the power m raised to the power 22 minus r, and 1 by x square raised to the power r. And if I simplify this, this becomes 22 CR x raised to the power 22 m minus mr minus 2r. Now see, we have two conditions. One, they're talking about this power of x to be 1, because power of x they are talking about. So let us put this 22m minus mr minus 2r as 1. And another condition that we have is this coefficient 22 CR for this value of x should be equal to nothing but 1540. So we have to solve this equation simultaneously and figure out the value of m. So let us see how this works out. So you will have to use a little bit of logic along with the equations in order to get to the answer. Now let us see how that works out. So if I take this 22, so this one, let us take. So if I try and factorize this part, and it can be written as 154 into 10. And again, if I divide this by 11, it is 11 into 4 into 10. See, now if you are writing 22 CR, you can see that it will be something like 22 factorial by 22 minus r factorial into r factorial. So logically speaking, there is going to be a 22 in the numerator part. So what we need to do here is basically, if I rewrite it, you can see that it can be written as 22 into 10 into 7. So from there you get this idea that there might be 3 terms. So a possible value of r, possible, I'm not saying it is the value, I'm saying a possible value of r can be 3. So let us check whether this satisfies for r is equal to 3 or not. So we are checking, and from there we will get our answer. If I check for r is equal to 3, let us see what happens. So 22c3, if I check, it becomes 22 into 20 into 21 divided by 3 into 2 into 1. And if I simplify this, you can see that what I'm getting here is 22 into 7 into 10, and this is the same value we are getting earlier. So from here we can conclude that, and this is a little bit of hit and trial, but this is making our life really simple. The value of r comes out to be 3. I'll also say that this cannot be the only solution, because if 22cr is equal to 1540, the same value will also come for 22cr n minus r, that is 22 minus 3. So you can see that the same value will also come for r is equal to 19. So r can have two possible values, 3 and 19. Let us check answer for both the cases. If I put r is equal to 3 here, it becomes 22m minus 3m minus 6 is equal to 1. So this becomes 19m is equal to 7. M becomes 7 by 19. Now this cannot be your answer because m is a natural number, so we need to neglect this. But if I do it for the other one, now let us see what happens. So 22m minus 19m minus 38 is equal to 1. Now here if you solve, the value of m comes out to be 13. And this can be your answer since m is a natural number. So it is a very interesting question. You will have to use your logic to come to the answer. Direct equation solving will not get you to the answer. Now the trick that we learned in the last question, where we do not just need to take the value of r, but n minus r in order to do the calculation, and will be played again in this question in 2019. If you look into this question, they have already given the coefficient of x is nothing but NCR, NC23. So if I write the general term, it is nothing but NCR x raised to the power 2 raised to the power n minus r, and x raised to the power minus 3 raised to the power r. So the value of that comes out to be nothing but NCR x raised to the power 2n minus 5r. Now, based on this question, if I just compare, so what they're saying is NCR is equal to nothing but NC23. So from here, there are two possible values of r. R is equal to 23. And another one of r would be n minus 23, because NCR is equal to NCn minus r. Now, this is where the most of the students will commit the mistake. They will only take the value of r as 23 rather than n minus 23, and where things will go drastically wrong. So let us take both the cases. Now, if I take the first case, let us see what value we are getting for n. If I take r is equal to 23 and substitute, this power is given as 2n minus 5r is nothing but given as 1. If I substitute this, 2n minus 5 into 23 will be equal to 1. And if you solve, the value of n comes out to be 58. And unfortunately, it is also in the answer. So this can go drastically wrong if you do not take the other case. So if I consider the other value for r, the value of r here in the next case is nothing but n minus 23. So let us do this calculation now. So 2n minus 5 times n minus 23 is equal to 1. And if you solve from here, the value of n comes out to be nothing but 38. Now, since we need to take this smaller value, hence 58 will not be the answer, 38 will be the answer, hence D option becomes correct. So this whole idea of checking for NCR and NCn minus r is very important in solving questions. Now, this kind of question that was given in 2023 has been asked earlier also. So in this question, we have to first find the sum of the series. And once you have figured out the sum of the series, then we can check the coefficient of x to the power 301. So let us first find the sum of the series. Now, once you look into this series, what you will observe is this series is nothing but a GP, geometric progression. So we'll have to apply the sum of GP. So A here is nothing but 1 plus x raised to the power 500. And the value of r is nothing but x upon 1 plus x. Now you can see here that the total number of terms here is nothing but 501. So if I apply my basic formula for sum of GP, it is nothing but 1 minus r raised to the power n by 1 minus r. And if I apply this formula, it is 1 plus x raised to the power 500 into 1 minus x upon 1 plus x raised to the power 501 divided by 1 minus x upon 1 plus x. And if I simplify this, what will I get is nothing but, after simplification, 1 plus x raised to the power 500. This will become, if I take LCM, 1 plus x raised to the power 501 minus x raised to the power 501 by 1 plus x raised to the power 501. And if you simplify this numerator denominator part, it becomes nothing but 1 upon 1 plus x. Now, if I simplify this, you can easily see that this 1 plus x part in the numerator and denominator is getting cancelled out. So what is ultimately left after this calculation is 1 plus x raised to the power 501 minus x raised to the power 50. Now, this is a very simple question. What we need to figure out is the coefficient of x raised to the power 301 in that. Now see, this term, second term, will have no contribution in that. So what we want from here is coefficient of x raised to the power 301 in nothing but 1 plus x raised to the power 501. If I do this calculation, very basic answer, so NCR will be the answer. So this is our answer. Now, there is a problem after this. The problem is that you will not find this in the options. If you do not carefully read it, probably will tick here and move on. But here, there is no 501. It is 500. So this is not a correct answer. But if you look into this answer, that is our second option. And most of the times, this will be done in binomial theorem. They will not give you the answer as NCR. Instead of that, they will apply this property and give the answer as NCN minus R. If you apply this property in this, what we have is 501C301 will be equal to 501C501 minus 301. So the answer becomes 501C200, and that is our option B. Now let us start with this next question. In this next question, this is a combination of the general term formula and the log. Let us see how this works out. So what they're saying is the third term. If I write the third term, that is nothing but T3. It can be written as 5C2 x to the power x to the base 2 whole square. The value of this term is given as nothing but 2560. If I simplify this 5C2, it is 5 into 4 by 2 x log of x to the base 2 whole square is equal to 2560. So you can see that this 10 and this 10 will get cancelled out. So what you are getting is x to the power log x to the base 2 whole square. This is equal to 256. That is nothing but 16 square. So the value of x log of x to the base 2 comes out to be 16. And now if I take log on both the sides, it becomes log of x to the base 2. Log of x to the base 2 and log of 16 to the base 2. If I do this, the power that I have written here using properties of log can be written in multiplication into log of x to the base 2. This is nothing but equal to 4. So you can see that log of x to the base 2 whole square is equal to 4. And that would mean that log of x to the base 2 can take two value plus minus 2. So value of x comes out to be 2 raised to the power 2 and 2 raised to the power minus 2. So one answer becomes 4 and the other one becomes 1. Let us check which is given in the question. D option comes out to be correct. Now let us move towards this next problem type. It talks about term from the end. So till now we were being asked term from the beginning of a series. Now we have been asked term from the end. So what you can use is a very clever trick. So for example, if you have x plus y raised to the power 10, and if somebody is asking you what is the fourth term from end, so what you can do is you can reverse the order of this series. So whatever was the fourth term from end in the old series becomes now fourth term from the beginning. If you exchange the order of x and y, now that term is going to become fourth term from beginning. And for that you have got a formula. And that formula is nothing but 10C3. So this becomes T4, that is 10C3 into y raised to the power 7 and x raised to the power 3. And it becomes very simple. So this neat trick can be used to solve all such kind of questions without remembering any kind of a formula. Now let us look into what kind of questions can be based on this idea. Let us look into this first question that was based on this idea. So they are talking about two first 0, 1, 0, 11th term. The first one is from the end of the binomial expansion. Second one is from the beginning. So first let us write the beginning one. If I write from the beginning, it will become nothing but 2022 C 1010. And since it is from the beginning one that we are writing, by 5 raised to the power 1012 will come, and then minus 5 by 2x raised to the power 1010. Now what they are saying is this is 1024 times. This into 104 times is equal to 1011th term from the end. So now if I want to write from the end, what is the trick that I have told you is basically reverse the order. So we will reverse the order. You can see in place of x I am writing y, in place of y I am writing x. By reversing this order, now what we can do is we can put the same power 2022. Once you have done this, now this question becomes quite simple, because in order to find the T1011, the answer is going to be nothing but 2022 C1010 minus 5 by 2x raised to the power 1012 into 4x by 5 raised to the power 10. In this manner we can write it. So if I write down this term here, it becomes 2022 C1010. This part is same. But instead of 4 by x, what we are getting is minus 5 by 2x raised to the power 1012. And the other term becomes 4x by 5 raised to the power 1012. If you put this, you can see that now we can cancel out this part on both the sides. So what is ultimately we are getting is 1024. And into what we will get is 4x by 5 whole square. Rest of the terms will get cancelled out. And here what we'll get is minus 5 by 2x whole square. Now let us simplify. So this 1024 can be written as 2 raised to the power 10. This will become 2 raised to the power 4. X square by 5 square. And on the right hand side what we are getting is 5 square by 2 square x square. If I take all the x square terms on the same side, it is x raised to the power 4. 5 raised to the power 4. 2 raised to the power 16. So x comes out to be, more appropriately, mod of x comes out to be 5 by 2 raised to the power 4 or 5 by 16. And if you look into the options, that is our option A. So the neat trick in doing all such questions is you reverse the order of terms and then you get the term from that. So no formula needs to be remembered for doing this kind of calculations. Now let us take one more question based on similar concept. Now here what they are asking is, if I take the fifth term from the beginning and fifth term from the end, the ratio is given. What I want is third term from the beginning. So there are two parts in the question. First they are talking about the ratio. From there we'll solve and get the value of n. Once I have got the value of n, I can use that value to find the third term from the beginning. So let us start with it. So if I write fifth term from the beginning, it is nothing but T5. So answer becomes NC4 2 raised to the power 1 by 4 raised to the power n minus 4 and 1 by 3 raised to the power 1 by 4 raised to the power 4. And if I write it from the beginning, it becomes NC4 and the terms will get reversed. 3 raised to the power 1 by 4 raised to the power n minus 4. 2 raised to the power 1 by 4 raised to the power 4. So what I have done again, I am qualifying my answer that what I am doing in the second part is I have reversed the order of this term. So what I am doing is I am writing 1 by 3 raised to the power 1 by 4. And the second term we are writing is 2 raised to the power 1 by 4 raised to the power n. And then we are writing the general term from the beginning. So NCR into 1 by 4 3 raised to the power 1 by 4 raised to the power n minus r and 2 raised to the power 1 by 4 raised to the power r. So this is what we have done. Now once you have done that, they are talking about the ratio. So if I divide them, so it becomes NC4 into 2 raised to the power 1 by 4 raised to the power n minus 4. 1 by 3 raised to the power 1 by 4 raised to the power 4. Divided by NC4 1 by 3 raised to the power 1 by 4 raised to the power n minus 4 and 2 raised to the power 1 by 4 raised to the power 4 would be equal to nothing but root 6. That is what is given to us. Once you have written that, see what you are seeing is I am not doing calculation till the last step because I know a lot of terms will get cancelled out and our life will become easy. Now once we write it down, we can see that these terms are getting cancelled out, and I can simplify in a better manner. If I write all the powers of 2 raised to the power 1 by 4 in one place, and 1 by 3 raised to the power 1 by 4 raised to the power n minus 8, this will be equal to root 6. And further, if I simplify, this 3 raised to the power 4 will come in the numerator, and it will become 6 raised to the power 1 by 4 raised to the power n minus 8 is equal to root 6. And still you can simplify it much more, and you can write this as nothing but 6 raised to the power n minus 8 by 4 is equal to 6 raised to the power 1 by 2. If you solve from here, n comes out to be 10. So the first part is done. Now what I want in this question is nothing but the third term from the beginning. So if I write it down, the third term from the beginning can be written as nc2 2 raised to the power 1 by 4 raised to the power 8 and 1 by 3 raised to the power 1 by 4 raised to the power 2. And here n also I know is nothing but 10. So let us write 10 in its place. And if I simplify this, what I get is nothing but 60 root 3. And that is nothing but option B. So there were two parts of this question. The first part entails using this concept of fifth term from the end, that I showed you how we can get it by reversing the terms. And then the second part is a very simple part, finding the third term. For that you have a formula. With this, now let us move on to the next problem type, that is term independent of x. Now what does this logic means is that term of series expansion in which the power of x becomes 0. That term is known as term independent of x. Now let us see what kind of questions are asked on this idea. So there is this 2023 question that is saying that the term independent of x, the value of that is given as 7315. You find the value of the alpha that is given here. So what we are going to do is we are going to write the general term in the first step. So 22CR x raised to the power 2 by 3 raised to the power 22 minus r alpha by x cube raised to the power r. So what we have got after simplification is 22CR alpha raised to the power r is our coefficient, and x raised to the power 44 by 3 minus 2r by 3 minus 3r. This is nothing but the power of x. Now for this to become term independent of x, the next step, what should happen is whatever we are writing on the power of x, this needs to become 0. So 44 by 3 minus 2r by 3 minus 3r becomes 0. If I simplify this, this is 44 minus 2r minus 9r equal to 0. So 44 minus 11r becomes 0. So the value of r comes out to be 4. Now in the third step, once we have done that, now let us find the value of alpha. So what is given is this 22c 4 into alpha raised to the power 4. This is given as 7315. All we need to do is do the calculation and find the value of alpha. So if I write it down, the first term can be simplified into 22 into 21 into 20 into 19 divided by 4 into 3 into 2 into 1 into alpha raised to the power 4, 7315. And if you simplify this, the value of alpha raised to the power 4 comes out to be 1. So the value of mod of alpha comes out to be 1. Hence our answer to this question is nothing but. So there are three simple steps in which you can solve such questions. Write the general term, put the power of x equal to 0, and then solve and answer whatever is asked in the question. Now let us reinforce the idea by solving another question of 2023. In this question, what they are saying is the value of the constant term of the term independent of x is nothing but alpha. And you have to find the greatest integer function of alpha. Now we both understand what is greatest integer function of x, so I will not go into that. So let us find the term independent of x. So for that, let us write the general term first. If I write that, it is 7cr thrice of x square raised to the power 7 minus r and minus 1 by 2 x raised to the power 5 raised to the power r. So if I write this down and simplify, what I get is 7cr into 3 raised to the power 7 minus r divided by minus 2 raised to the power r, and then the power of x becomes 14 minus 2r minus 5r. You can see that in the next step, this power of x needs to be 0, and this is nothing but 14 minus 7r. If I put this equal to 0, the value of r here comes out to be 2. Once I get this value, in the third step, our life becomes extremely easy. We can find the value of alpha, that is nothing but the constant term, by putting the value of r as 2. So this becomes 7c2 into 3 raised to the power 5 by nothing but minus 2 whole square. And if I solve this, it comes out to be 1275 point something. So if I want to find the greatest interior function of alpha, it comes out to be 127. So there is a little bit of calculation, but that you can do and get to the answer. So it is very simple, 3 simple steps to get the answer. Now let us go into this very interesting question of 2023. Now this mammoth question, I am calling it mammoth because it is gigantic. The amount of calculation they want us to do in one question is like tremendous. Was asked in 2023. In this question, if you look at carefully, there are 3 parts of the question. The first part talks about a constant term in the expansion of this part. The second part talks about the coefficient of x raised to the power minus 3l. And third part talks about the value of alpha l minus beta. So let us solve all the parts one by one and then connect them to come up with an answer. And most of the times you'll find in JEE means that there are multiple parts connected with each other. So let us start with the first part. The first part says that the constant term in this expansion. So for that, now we are going to write the general term NCR. X raised to the power 5 by 2 raised to the power 9 minus r, and minus 4 by x raised to the power l raised to the power r. And if I simplify this part, what I'm getting is nothing but 9cr minus 4 raised to the power r in the denominator, 2 raised to the power 9 minus r. This is one part, that is the coefficient part. And the power of x comes out to be nothing but 45 by 2 minus 5r by 2 minus LR. See, in such kind of question, it is very important. It is very, very important that you do not miswrite or miss out onto something, and otherwise you will not get the answer. If I look into this, you can see that if I want to find the constant term, this needs to be 0. And more importantly, this is one of those questions in which the value of coefficient is given. So what they have given is nothing but this part. So the value of this part is given. So our idea would be to let us write 9cr minus 4 raised to the power r by 2 raised to the power 9 minus r. What the first part is to guess the value of r from here, so that the value of this part becomes minus 84. From that, get the value of r and then put that value of r here to get the value of l. That is what we want to accomplish here. Now this kind of question we also have done earlier, when we have been given the value of coefficient and we have to find the value of r. And I told you that this you cannot get by solving some equation. This can definitely be got by guessing the value of r. That is much faster and convenient method. So in this case, since they are giving the value as negative, it is obvious that r needs to be an odd number. Otherwise, minus will not come out of minus 4 raised to the power r. Now, for that, if you guess the value, the possible values of r can be either 1, or it can be nothing but 3, then 5, then 7, then 9. So out of this, 1 I can clearly see that it cannot happen because the numbers would not satisfy that. So let us try the another value, that is nothing but 3, because it is the closest and the simplest to do. If I put that, this becomes 9c3 into minus 4 raised to the power 3 by 2 raised to the power 6. And if I simplify, it comes out to be minus 84. So this value is getting satisfied, and the value of r is equal to 3. If you do some basic calculation of on 84, you can also guess the value of r from there. Now, if I move further, what you can see that this r value we can put here, because the another condition that we have got from here is, since this is the constant term or term independent of x, the value of 45 by 2, 5 into, let us put the value of r, minus L into 3 should be equal to 0. If you solve, the value from here comes out to be 45 minus 15 minus 6L is equal to 0. So this is nothing but 60 minus 6L becomes 0. So the value of L comes out to be 5. So the first part we have solved all this question. Now let us move to the second part. If you look into the second part, what they are saying is x, the coefficient of x is to the power 3L. So the value of L that we got here becomes the input for the second part. If I put here x raised to the power minus 15 we are getting. So you want to find the coefficient of this part. So now let us compare the value of minus 15 with 45 by 2 minus 5r by 2 minus L we can put here is 5r. From there, let us get the value of r. From there, get the value of coefficient. From coefficient, find the value of alpha and beta. So if I do this becomes nothing but minus 30 is equal to 45 minus 5r minus 10r. And from here, if I solve, what I'm getting is minus 75 will be equal to minus 15r, or the value of r comes out to be 5. So this we have got from here. Now let us use this to find the coefficient. So if I find the coefficient from here, my coefficient would be equal to 9cr. So r, let us put here as nothing but 5. So 9c5 minus 4 raised to the power 5 by 2 raised to the power 4. This we will get. And if we simplify this, this is 9 into 8 into 7 divided by 4 into 3 into 2 into 1 into minus, let us take it out, 4 raised to the power 5 by 2 raised to the power 4. And now if I simplify this part, what I am getting is nothing but this 4 into 2 will get cancelled out from it. 3 will also get cancelled. So we have 2 here. And if I simplify, what I am getting is minus 63 into 2 into 2 raised to the power 10 minus 4. So the answer comes out to be minus, more importantly, 2 raised to the power 7 into minus 63. Why am I writing so? Because in the question they have given that the value of this part is 2 raised to the power alpha into beta, and beta is smaller than 0. So from here the value of alpha comes out to be nothing but 7, and the value of beta that we are getting from here is minus 63. So now let us take this value and go to the third part of the question. Now the third part of the question says that alpha L minus beta modulus, what is this value? So let us put all of these values here. So alpha came out to be 7, L was nothing but 5, beta came out to be minus 63. So if you simplify this, the answer comes out to be 98. So you can see that this is a mammoth or a gigantic question. There are multiple concepts that are interacting, and more importantly, there are 3 parts of the question that you need to segregate. If you don't segregate, you cannot solve such kind of questions. So what I am doing is, I am breaking it down into 3 different questions. The first part is term independent of x. The second part is finding the coefficient, and the third part is simple substitution. Now this is a very interesting question that came in 2022. And then there are multiple such questions that came in subsequent years or the years after that. The core concept of this question is we are combining the concept of term independent of x with the concept of am is greater than or equal to gm. So this is the whole problem type that developed because of combination of these 2 specific types of problems. So let us see how to solve such question. The first part is to find the term independent of x. That can be found by writing the general term. So 15cr t square x raised to the power 1 by 5 raised to the power 15 minus r, and 1 minus x raised to the power 1 by 10 by t raised to the power r. So now if I find the power of t here, it is nothing but 10 minus 2r, 30 minus 2r minus r. So you can see on the power of t we have nothing but 30 minus 3r, and this is important because this will become 0 when the value of r becomes 10. So the coefficient or the term independent of x, it will be the same, comes out to be nothing but 15c10 x raised to the power 1 by 5 raised to the power 5 and 1 minus x raised to the power 1 by 10 raised to the power 10. So once you have got this, you can easily observe and simplify this, and it will come out to be 15c10 into x into 1 minus x. So this is very important. Why this is important? Because now they are asking in the second part that what is the maximum value of this part. So now if I go into this, so what I can do is, we have this concept of am is greater than or equal to gm. So if we have a plus b by 2, this is always greater than or equal to ab raised to the power 1 by 2. And since c 1 by x is in the power of 1 by 10, obviously it needs to be positive. So the condition is here is that a and b both needs to be greater than 0, and that is getting satisfied here. So if I take my a as nothing but x and b as nothing but 1 minus x by 2, this will be greater than equal to x into 1 by x raised to the power 1 by 2. And if we simplify this, you can see that x into 1 minus x needs to be smaller than equal to nothing but 1 by 2 whole square or 1 by 4. So the maximum value can occur at 1 by 4 when x and 1 by 1 minus x will become equal. So the maximum value of this part becomes 15c10 into 1 by 4. Now what they are saying is, see, this value is equal to k, and this we can consider as our last part of the question or the third part of the question. In the third part, they are asking the value of nothing but 8k. If you multiply by 8, this becomes nothing but 2 times 15c10, and if you simplify this, this comes out to be 6006. That is nothing but our answer. Now we can find the underpinnings of the last question in this question as well. So we have to do the same thing what we did in the last question. So I'm doing it twice, so you should understand the concept really well. So if I write the term independent of x in this question, what we are getting is nothing but 10cr alpha x raised to the power 1 by 9 raised to the power 10 minus r, beta x raised to the power minus 1 by 6 raised to the power r. So if I simplify this, this is 10cr alpha raised to the power 10 minus r, beta raised to the power r. These are the coefficient part, and the power of x here comes out to be 10 by 9 minus r by 9 minus r by 6. And in order to this to become independent of x, this needs to be 0. If I put 10 by 9 minus r by 9 minus r by 6 equal to 0. So this will become 20 minus 2r minus 3r equal to 0, or 20 minus 5r equal to 0. R is nothing but 4. Once you have figured this out, let us start with the second part. So if you do this, the term independent of x becomes 10c4 alpha raised to the power 6 beta raised to the power 4. Now this is important because see, now they're asking what is the maximum value of this. So again, since alpha and beta are greater than 0, we can apply am is greater than equal to gm. So if I apply it between alpha cube and beta square, this divided by 2 will be greater than equal to alpha cube beta square raised to the power 1 by 2. The value of this part is given as 4 here. So 4 by 2 is nothing but greater than equal to alpha cube beta square raised to the power 1 by 2. So alpha cube into beta square is always smaller than equal to 4. Hence, now what we can say is the term independent of x that we figured out was nothing but 10c4 into alpha raised to the power 6 beta raised to the power 4. So the maximum value of this term will come out to be 10c4 into nothing but 4 square. And now this they have given in the third part. Now let us move towards the third part. They have given this equal to 10k. So if I simplify this, this becomes a 10 into 9 into 8 into 7 by 4 into 3 into 2 into 1. Nothing but 4 square. This is nothing but 10k. If you simplify from here, the value of k comes out to be nothing but 336, which is nothing our option C. You can again see there were two parts of the question. The first part talks about the term independent of x, and after that we apply am greater than equal to gm to get to the answer. This last question, based on this concept, again connects the idea of independent term with trigonometry, and again we are looking into the maximum minimum values only. So let us write the general term in order to find the term independent of x. So it is nothing but 16cr x by cos theta raised to the power 16 minus r and 1 by x sin theta raised to the power. So if you look into the power of x here, that is going to be nothing but 16 minus 2r. So clearly we can see that the term independent of x will come at nothing but r is equal to 8, and it comes out to be 16c8 by cos raised to the power 8 theta into sin raised to the power 8 theta. And if I do a little bit of manipulation and multiply and divide by 2 raised to the power 8, something magical happens. This becomes nothing but sine 2 sine theta cos theta inside power 8. And this comes out to be nothing but 2 raised to the power 8, 16c8 by sine raised to the power 8 to theta. Now, why is this important? Because in the minimum value of this, so if I take this in the next part, let us see what happens. So in the second part, if I want to find the least value, so here the important word is the least value. So the least value of this will come in this duration pi by 8 to pi by 4, add the value pi by 4. Because for this pi by 4, sine 2 theta will become maximum. So let us find the value of sine 2 into pi by 8, pi by 4, and this comes out to be nothing but sine of pi by 2, that becomes 1. So you can see that the value of L1 here is coming out to be nothing but 2 raised to the power 8, 16c8. Now let us move towards L2. So for L2 part, what we need to consider is the value of sine 2 theta, sine 2 theta in this duration pi by 16 to pi by 8. So in pi by 16 to pi by 8, again the least value will come for this function when theta becomes pi by 8. So if I put this pi by 8, this becomes sine of pi by 4, and that is nothing but 1 by root 2. And if I put this, the value of L2 from here comes out to be 2 raised to the power 8, 16c8, and this becomes 1 by root 2 raised to the power 8. 16 times 2 raised to the power 8 into 16c8. Now what they are asking is, in the question, nothing but ratio of L2 is to L1. So let us divide L2 by L1 in the third part. So if I do that, my answer becomes nothing but 16 is to 1. Hence my option D comes out to be correct. So it is a simple question involving maximum and minimum value, or the range kind of questions in trigonometry. They are combining with that with independent term. Type 4 problem that we are going to deal with is nothing but problems involving middle term of binomial coefficient. Now, if I look into a binomial coefficient in which the value of n, so if we have x plus y raised to the power n, now the value of n, if I take this as 4, as a result, the total number of terms will become 4 plus 1, that is 5. So the middle term would be nothing but 2 plus 1, that is nothing but the third term. What we are saying is, if n is even, there is one middle term, that is nothing but n by 2 plus 1th term. And if you have something like this, x plus y raised to the power 5, in this case, total terms are nothing but 5 plus 1, 6. So there are two middle terms. One is 5 plus 1 by second, and the another one is nothing but 5 plus 1 by 2 plus 1. So as a result, we will have a third term and fourth term, which will be respectively the two middle terms. Now this idea has been summarized in the form of the table that is given to you. One more important fact regarding middle term is basically, if I look into middle term, then the value of binomial coefficient. So we are not talking about coefficients. Coefficients are different. Binomial coefficients are different. The value of binomial coefficients for middle term is nothing but maximum. Now based on this, what questions were asked in JEE? Let us see. Let us start our discussion with the first kind of problem that was asked in 2019. In this term, they are talking about the middle term. Value is given to us. What they are asking is, corresponding to this, what is the real values of x possible and sum of those values. So this is the question. So first let us write the middle term. Now this, the value of n here is even. So there is only one middle term, and that middle term is nothing but t n by 2. So 8 by 2 plus 1th term. So that terms come out to be t5. If I write that one, it becomes 8c4 into x cube by 3 raised to the power 4 into 3 by x raised to the power 4. So this is the middle term that we are getting. And if I simplify this, this is the first part of the question. And if I simplify this, it becomes 8c4 8c4 into x raised to the power 12 by 3 raised to the power 4 into 3 raised to the power 4 by x raised to the power 4. And if I simplify this, the value of this will come out to be 8c4 into x raised to the power 8. And in the question they are saying in the second part that we have to find is the value of this is given as 5670. So 8c74 into x raised to the power 8 is equal to 5670. Now in order to get the value of x raised to the power 8, let us take 8c4 on the other side. If I write it down, it is 8 factorial by 4 factorial into 4 factorial. So 8 into 7 into 6 into 5. And divide by 4 into 3 into 2 into 1. So 4 into 2 I can cancel out as 8. And 3 if I cancel out, it becomes nothing but from 6 I will get 2. And 5 into 2, 10. This will again get cancelled out. And again if you divide the value of x raised to the power 4 comes out to be equal to 81. That is nothing but 3 raised to the power 4. And if I solve this, there are two values of x that we'll get, plus minus root 3. These are the two real values that we are getting. And now if I add them up, that is from where we'll get our answer. If I add them up, then root 3 plus minus root 3 will come out to be 0. That is nothing but our B option, which comes out to be as our correct answer. Now this next question that came into 2020 talks about the relation between the greatest value of a binomial coefficient and the middle term. So you can see that the greatest value of this will come at the middle term. So corresponding to that, the value of P here will become nothing but 10. Corresponding to that, the value of Q here will become nothing but 10. And corresponding to that, again the value of R will also become 10. So at the middle term, the binomial coefficient will achieve its maximum value. If I write it in this manner, now what they're saying is this is equal to A, this is nothing but equal to B, this is nothing but equal to C. So if I write A by 19 C 10, it will be equal to B by 20 C 10, and it will be equal to C by 21 C 10. All of them will be equal to 1 and hence equal to each other. So if I take this ratio and simplify, I should get my answer. So let us see what comes. So if I simplify this, it becomes 19 factorial by 10 factorial into 9 factorial. This becomes B by 20 factorial by 10 factorial into 10 factorial and C by 21 factorial by 11 factorial into 10 factorial. And if you simplify this, what you can observe here is this 10 factorial will get cancelled, and 19 factorial also if I cancel, this will become 19, and here it will cancel out and become 20, and here this will cancel and become 21 into 20. Now I can multiply by this 10 factorial, 11 factorial, which is the greatest factorial that is left here. If I do so, it becomes 11 factorial by 9 factorial. This becomes nothing but 11 factorial by 10 factorial. And this becomes nothing but 1. Now, if you simplify this, this is A by, this would have become 1. So if I write this down, it is nothing but 11 into 10. And this if I do it, it is 20 into 11. And if I write, it is nothing but 21 into 20. This 10 again I can cancel out. And what we have got is a ratio A by 11 is equal to B by 22 is equal to C by 42. And this comes out over option A. Quite a simple question based on basic calculations of factorial notation. Now let us move on to this 2020 question. Again, a gigantic question. I don't know why these kind of questions are made, now which have so many calculations in it. So let us look into the question. The question talks about 3 different series. This is the first part. In the part 1 of the question, what they want us to do is find the coefficient of the middle term. They do not want us to find the middle term, but the coefficient of the middle term. So if I write the middle term for the first one, it is going to be nothing but third term. So that comes out to be nothing but 4c2 1 by root 6 whole square then beta x whole square. And if I look into just the coefficient part, it comes out to be 4c2, that is nothing but 6 into 1 by 6 into beta square, and that is nothing but beta square. This is the first part. This is the first series. Now let us move on to the next series. So if I try and find the middle term from there, it would be nothing but the second term. And if I write that, it is going to be nothing but minus 6 beta x. And from here, the coefficient comes out to be minus 6 beta. And this is what is important to us. And in the third one, if I talk about the middle term, it is going to be fourth term. And if I find this, it is going to be 6c4 into minus beta by 2 x raised to the power 4. So to the power 3, and we need to write 3 here. And if I do so, my coefficient comes out to be 6c3. So that is nothing but 6 into 5 into 4 by 3 into 2 into 1 by 8. And if I simplify this, you can see that what we are getting from here is this 3 will cancel out, 2 we will get. And 2 into 4, 8 will get cancelled out. So 5 by 2 will get. So minus 5 by 2 beta cube. This is nothing but the coefficient. Now once you have got the coefficient in the part 1, then comes the part 2. They are saying that now these are the first 3 terms of an equation. What does that mean is, now I have to solve an arithmetic progression. And then there comes a third part where we will have to do the final calculation and get to the answer. So let us do the part 2 of the question. And usually we have seen that mains consist of a series of standard problem types. Now in this, the first one, or the A, is nothing but my beta square. This is my first term. The second term comes out to be minus 6 beta, and the third term is minus 5 by 2 beta cube. So if I use the relationship between the 3 terms, consecutive terms in an arithmetic progression, twice of middle term is going to be equal to the sum of extreme terms. And here I can cancel out beta because beta is greater than 0. It is given in the question. So I can cancel out, this becomes minus 12 is equal to beta minus 5 by 2 beta square. And if I simplify, this becomes nothing but minus 24 is equal to 2 beta minus 5 beta square. And if I simplify this quadratic, it becomes 5 beta square minus 2 beta minus 24 equal to 0. And if we solve this quadratic, let us see what is the value of beta that we are getting. It is nothing but 2 plus minus root of b square minus 4ac. So I have done minus into minus plus by 2a. And if I simplify this, let us see what we are getting. So 2 we can cancel out. And what we are getting is 1 plus minus 11 by 3. Now here by 5, sorry. And here interestingly, what we can see is beta is greater than 0. So we need to consider the plus sign. So this comes out to be 12 by 5. Now this becomes the background for doing the part 3 of this question, where they talk about, where they want us to find the value of 50 minus 2d by b square. 50 minus 2d by beta square. So here see, 50 is fine. That we can write 2 times d. And if I want to find d, again what I will have to do is I will have to take the difference of the first 2 terms. That is minus 6 beta minus beta square. And if I do so, 6 beta is nothing but 12 by 5. Beta square is 12 square by 5 square. So what we can do is we can take this 12 by 5 common. Also we can take this 6 and minus sign also common. So what we are left with is 1, a plus sign. Here we'll get 2 by 5. And if I simplify, then this becomes minus 12 into 6 into 7 by 5 square. This is what we are getting. And if I put the value of d here, this is nothing but sign will become plus 12 into 6 into 7 by 25 divide by 12 square by 5 square. So you can see that your 5 square is getting cancelled out. 12 is also getting cancelled out. If I cancel 6 also, this becomes 2. and 2 also we can cancel. So answer is nothing but 50 plus 7. That is nothing but 57. So this is a gigantic question. There are three different parts. And it is filled with a lot of calculation. Part 1 consists of finding the middle terms. Part 2 consists of applying the concepts of arithmetic progression. And part 3 consists of doing the calculation. So this is a gigantic question. It's bound to take some time. Now let us jump on to the next problem type. That is our fifth problem type. Questions based on rational terms. So let us look into this concept of problems using this question that came in 2023. If you look into this question, a binomial expansion is given to us. And if I write a general term of this, it is going to look something like 680 CR 3 raised to the power 1 by 2 raised to the power 680 minus r and 5 raised to the power 1 by 4 raised to the power. So what we are getting in the power of 3 here, so 680 CR is fine, but what is in the power of 3 that is important, 680 minus r by 2. And in the power of 5, there is nothing but r by 4. So see, now what we want is, we do not want fractions in the power. So fractions in the power will not come if r becomes a multiple of 4. So if r comes out to be this form, then here there is going to be no fractions. Now let us also check what will be the value of this part. So for this part, if I put r as nothing but 4k, you can see this will also not be a fraction. So all the values that we want is of this type. And r is equal to 4k. Now let us write how many such terms will be possible. So if I keep writing those terms, now this is the second part of the question. So the first term will be 0, then 4, then 8, and this will go up till nothing but 680. Because 680 is also divisible by 4. So if I want to find the total number of terms, I can apply the formula of a plus n minus 1 into d. Here our first term is nothing but 0, n minus 1 is fine, the d is nothing but 4. If you find the value of n from here, it comes out to be 171. Hence the answer of this question is 170. Now there is a word of question while solving such question is, when you are writing the general term, whatever term is more in the denominator, like here there is 4, that should be below r. This will make your problem solving simpler. So I could have also reverse the term and return the general term. That is also fine. But if I take the bigger number in the denominator, in the power, your calculations will become simpler. Your question will be solved faster. Now in 2022, the same question came, but in reverse order. So instead of us telling them how many number of integral terms are there, they are telling us that the total number of integral terms are nothing but 33. You give me the value of that. So again, we'll write the general term. So NCR 3 raised to the power 1 by 2 raised to the power n minus r and 5 raised to the power 1 by 8 raised to the power r we can write. So if you write it down, it is NCR 3 raised to the power n minus r by 2, 5 raised to the power r by 8. So now we can see from here, this term we need to start from this term because the denominator in the power is maximum. So r needs to be a multiple of 8k. If r is a multiple of 8k, also n minus r by 2 needs to be an integer. If I replace r by 8k by 2, now this will become an integer only when n is even. So we also get an idea that n needs to be an even number. Now this was my first part. In the second part, what I can do is, let us write this term. So if I start writing that, then it will be 0, then 8, then 16, so on and so forth. And the term that we want is n in this series. If I write this out, now what is going to happen is, if I write this n here, if I want to find, to 0 plus total number of terms they are giving is 33. So 33 minus 1 into d. D here is nothing but 8. If you simplify this, the value of n comes out to be 256, and that is nothing but option C. So it is quite a simple question, just ask in the reverse order. The next problem type, or the type 6 problem, is based on greatest term. Now what does greatest term mean? Let us understand that first, and then we'll move on to the problems that this will cater to. So now what does greatest term mean? So if we have, let us say, the expansion of 1 plus x whole square, then this can be written as 1 plus 2x plus x square. So now we have three terms in this expansion. So now what we want is the greatest term. See, you can see that the value of the greatest term is dependent on the value of x here. So for example, if I take the value of x as nothing but 4, then you can see that the first term will remain 1 only, the second becomes 8, but the last one becomes nothing but 16. So my third term is the greatest term in the expansion. But in case if I take the value of x as nothing but 2, in that scenario, let us say, and now let us say it as 1, then let us see what happens. If I take x as 1, my first term remains 1, the second becomes 2, and the third also becomes 1. So now the greatest term is shifted towards the second term. And in the third part, if I take the value of x as nothing but 1 by 4 and write the expansion, the first term still remains 1, the second becomes 1 by 2, and the last becomes nothing but 1 by 16. So your greatest term is shifted towards 1. So what we can see is when we are taking greatest term, it depends on the value of x. That is the first important point to be noted. Second is based on different values of x, the greatest term will keep shifting in the series. So how to find it? Now what we are doing is, in order to do this, if we say that tr plus 1, if this term is the greatest term in the expansion and of x plus a raised to the power n, we are saying that this is the greatest term. What does this mean for some value of x is, this is going to be greater than the previous term, that is the rth term. And this is also going to be greater than tr plus 2, that is the next term. If I write these two conditions and simplify, I get this expression that is written here. So if I take the value of t as nothing but n plus 1 by 1 plus a by x modulus, what does this say is the value of r here will lie between nothing but t minus 1 and t. Now this result is simple enough to remember, and we will remember this result, and from here we will try and solve the question. Now let us see what kind of question JEE has asked on this idea. Now this question came in 2022 and I can expect one of the questions in 2023 papers also. Now let us see what this question talks about. If you look into this question, and if I make a logical map of how concepts are getting connected, but they are talking about a ninth term in this increasing powers of 6x and in this series to be greatest at x equal to 3 by 2. So the first part of the question talks about greatest term. This is the first part of the question. From here we want to get the value of n naught, that is the least value of n. Now there is a second part that talks about a ratio of coefficients. This is the next part. From here we need to get the value of k, and then there is a third part in which we have to find the value of n naught plus k. So this is how the question will work out, and most of the cases the standard problem types will stack together like this in sequential manner and generate a JEE means or advanced level question. Let us see how this question proceeds. So let us first solve the first part, greatest term part. So what we have given this a plus x raised to the power n, and for this they are saying that this t ninth term is the greatest term. So this is nothing but tr plus 1. So from here if I get the value of r, it is nothing but 8. So what I can write is, if I find the value of my t that earlier I defined as n plus 1 by 1 plus a by mod of x, that can be written now as n plus 1 by 1 plus a here is nothing but 3. In place of x, 6x is written. The value of x is 3 by 2. If I put it here, it becomes n plus 1 by nothing but 1 plus 1 by 3 or 3n plus 1 by 4. Now this is what we are getting. If I take this part further, what we know is the value of t minus 1. R lies between t minus 1 and t. So if I put it here, it is n plus 1 into 3 by 4 minus 1. And then this is n plus 1 into 3 by 4. And the value of r also they have given. So let us also substitute the value of r here. R in this case is nothing but equal to 8. If I put this value and simplify, then 3n plus 3 minus 4. If I multiply by 4 on both the sides, this is 32. And this is n plus 3n plus 3. If I take the first part, let us simplify and then take the first part. This is my first part. And the second part is 32 is smaller than or equal to 3n plus 3. You can see that a lot of small concepts getting used here and there. And if I simplify, the value of 3n from here comes out to be equal to 33. N is smaller than or equal to. This is my first inequation. The second says that my 3n is greater than or equal to 29, or n is greater than or equal to 29 by 3. So if I plot them on the number line, this is how they look like. What they're saying is there is this 29 by 3 and then there is 11. So 29 by 3 is smaller than 30 by 3, that is 10. So this is what has happened. We are looking into values between these two values. So you can see that there are two values of n. Since n is also an integer, there are two values of n that are possible. One value is 10 and another value is 11. So for n now we have figured out that there are two values, 10 and 11. And since question talks about an n naught, that is the smaller of these two values, that comes out to be 10. Now everything needs to be considered with respect to this value. Let us move further. So this is the first part. Now let us move to the second part, that is the ratio wala part. So now what we have is 3 plus 6x raised to the power n. In place of n, now let us write the value of n as 10. So if I take this, what they're saying is the coefficient of x raised to the power 6. So if I write that, the coefficient, so let us write the coefficient of x raised to the power 6, that is nothing but 10c6, 3 raised to the power 4, 6 raised to the power 6. This is what is the coefficient of x raised to the power 6. If I divide this by 10c3, because x cube coefficient would be nothing but 3 raised to the power 7 and 6 raised to the power 3. The ratio is equal to k. This is given to us. Now if I simplify this, let us see what I get. See, 10c4, 10c6 can be written as 10c4 by 10c3. And if you simplify this, this becomes 6 raised to the power 3 by 3 raised to the power 3. And if I again simplify this, this is 10 minus 4 plus 1 by 4 into 2 cube. So you can see that if I simplify this value, this comes out to be 7 into 2, that is nothing but 40. If you are finding this difficult, so there is an identity. If you remember that identity, it is much faster. If you don't remember, you can do the calculation. So the identity is NCR by NCR minus 1 is equal to n minus r plus 1 by r. If you do not remember this identity, it is totally fine. You can do the calculation and get it. Once you have done this, let us move to the third part. Now third part talks about finding the value of n naught plus k. Now n naught we have solved, came out to be 10. K we have solved, has come out to be 40. If I add, the answer comes out to be 20. So it is quite a complex question at the level of number of concepts getting involved, but you can split it and do it very simply. Now let us start with next problem type. This is nothing but multiplication of binomials. So now in earlier cases, we had one binomial expansion. In this case, we'll be having two binomial expansions. We'll have to multiply them and then comment upon something that's given in the question. Let us start with the question that was asked in 2023. In this question, what they're saying is if they multiply these two terms, what they want us to tell is basically the value of 2p plus 3q when the coefficient of x is 4 and the coefficient of x square is minus 5. So I've developed a technique which can be used in solving all such questions. So what you can do is you can make a small table. In this table, we will assign different kinds of powers to first and second binomial expansion. So let us see how this works out. So if I want to find the coefficient of x raised to the power 1, then let us say if the first one contributes x raised to the power 0, the second one will have to contribute x raised to the power 1. And vice versa, if this contributes x raised to the power 1, this will have to contribute x raised to the power 0. Now, if this happens, the coefficient of the first one will be PC0. The coefficient of the second term will be Q minus QC1. The coefficient in the second part would be nothing but PC1 and nothing but QC0. If they multiply, in this case, the coefficient will become nothing but QC1 into PC0. And the second case, the coefficient will become nothing but PC1 into QC0. So if you simplify the first one, it comes out to be minus q. The second one comes out to be p. And their sum will come out to be nothing but p minus q. And the value of this coefficient in the question is given as 4. So the first equation comes out to be p minus q is equal to 4. This is the first part. Now all we need to do is replicate these steps one more time for x square. So if I do the same thing for x square, 1 plus x raised to the power p, again we'll make the same table. And this table method is highly useful in solving all such questions. So if this contributes 0, this will have to contribute to 1, 1, and then 2 and 0. These are the possible cases. If I take the first case, the coefficient would be PC0. The coefficient would be nothing but QC2. In the second case, it becomes PC1 minus times QC1, and then PC2, and here the coefficient becomes QC0. So if I multiply the coefficient, it is nothing but PC0 into QC2. In the second case, it becomes PC1. Minus sign will come into QC1, and in the third one, it becomes PC2 into QC0. If I simplify the first one, it is nothing but q into q minus 1 by 2. If I simplify the next one, it is nothing but minus pq. If I simplify the third one, it is p into p minus 1 by 2. Let me show you the calculation. So this is how it works out. Now once you have done this, your life becomes very simple, because what we need to do is we need to take sum of these, and that is given to be nothing but equal to minus 5. So let us do that. So if I sum it up, it is q square minus q by 2 minus pq plus p square minus p by 2 is equal to minus 5. And if I simplify this, this becomes nothing but q square minus q minus 2pq plus p square minus p is equal to minus 10. Or what we can write is p square plus q square minus 2pq. This becomes the first part. Then minus p plus q equal to minus 10. P minus q whole square minus p plus q is equal to minus 10. So if I substitute this value, this becomes 4 square minus p plus q is equal to minus 10. So the value of p plus q from here comes out to be nothing but 26. Also now we know the value of p minus q, that was nothing but 4. And now the value of p plus q, that has come out to be 26. So if I add them up, twice of p comes out to be 30, or p is nothing but 15. And if you have got the value of p, now if I subtract these equations, what I get is twice of q, and that will be equal to 22. So q becomes nothing but 11. So if I want to find the value of 2p plus 3q, let us see what 2p plus 3q comes out to be. So we have figured out this value, 2p plus 3q. So 2 into 15 plus 3 into 11. This is going to be our answer. So our answer comes out to be 30 plus 33, that is 63, which is nothing but D option. So as you saw in the last question, this table technique is extremely useful in solving questions. Now let us move on to this next question. In this next question, if you look into this question, whatever is given inside this power, that can be factorized. How can we factorize that? So if I just take x square common from the last two terms, it is also going to become 1 plus x. So first I'm just looking into the part that is inside the brackets. If I do that, I will get 1 plus x into 1 plus x square. So what you have been given in the question is nothing but, if I put the powers here again, this will be 6. Here also the 6 will come. This is what the question is. So again, we are multiplying two binomial expansions. So again, we can make our table, because this table method is extremely useful in solving all such kind of questions. All you need to do is you need to make the table, and you need to do this question. So now we can see that in order to get x raised to the power 4, that is what they are asking. If the first one contributes x raised to the power 0, second one I'll have to contribute x raised to the power 4. Now x raised to the power 1, x raised to the power 3, x raised to the power 2, x raised to the power 2, x raised to the power 3, x, and x raised to the power 4, and x raised to the power 0. Now if you closely observe the second expansion, and if you write the general term from the second expansion, it is going to be 6cr x square raised to the power r. So what is happening is, whenever you will put a value of r, you will always get powers in even terms. So x cube and x will never come. So though we have written these cases, these two cases will never happen. So let us delete them. So these are the possible cases that we have now. So x to the power 0, x to the power 4, x square, x square, x to the power 4, x to the power 0. Now let us write the coefficient. So first one, if I write the coefficient, it is nothing but 6c0. In the second one, this will happen when the value of r will become 2. So this becomes 6c2. This becomes 6c2 and this will become 6c1 and this will become 6c4 and this will become 6c0. Now if I multiply the coefficients, what I am getting in the first part is 6c0 into 6c2. The second part becomes 6c2 into 6c1 and the last part becomes 6c4 into 6c0. All we need to do is basically find the value of this NCR and get our answer. So if I see what is the value of 6c2, it is nothing but 6 factorial by 4 factorial into 2 factorial. So this becomes 6 into 5. If I divide by 2, this becomes 3. So this is nothing but 15. So you can see the value of first term comes out to be 15. The second one, 62 is already 15. The second term will become 6. And in the third part, if I do it, I will have to find 64. But 64 will be equal to 62 only because NCR is equal to NCN minus R. So this can also be written as 15 into 1. So if you add all of these up, whatever is given to us, you will have 15, then 1 plus 6 plus 1. So it will become 8. So 15 into 8 is going to our answer. That is nothing but 120. So it is quite a simple question if you use this table method for solving it. Now this next question is also extremely easy because now what we need to do is you need to understand the format of the last question that we solved. The standard method was to convert it into two binomial expansions, use the table method and get to the answer. So your method should be how to reduce this question into earlier question, right? So what we need to do in this question is very simple. If I take this 1 minus x out from the second term, then this 1 minus x raised to the power 9 will remain. And what we have is 1 plus x square raised to the power 9. Now the first two terms can be grouped together. It will become 1 minus x square. And the other terms can be grouped together. It will become 1 minus x into 1 plus x square raised to the power 9. And you can see this is nothing but the expansion of 1 minus x cube. So what you are getting is 1 minus x square into 1 minus x cube raised to the power 9. And now either you can use the table method or you can even do it more simply just by distributing it. So if we have, you can see there are two terms. In the first one we can write as 1 minus x raised to the power 9 and the second will become x square into 1 minus x cube raised to the power 9. So if I want the coefficient of x raised to the power 18, both the terms will contribute. So this will also contribute and the second term will also contribute. Now in the first term, if I want to write the contribution, I will have to write the general term. So it is NCR minus x cube raised to the power r. So you can see that the power will increase in multiples of 3. So if I want 18, in this first case, the value of r needs to be nothing but 6. And if I put r is equal to 6, 3 into 6 will become 18. And the coefficient in that case becomes 9c6. And I can simplify this for getting the answer. So if I simplify, it is 9 into 8 into 7 by 3 into 2. So this becomes 3, this becomes 4. This is nothing but 21 into 4, that comes out to be 84. This is the first part. Now if I look into the next part, what you need to understand in the next part is, see this part, if it has to contribute powers of x raised to the power 18, you can see there is an x square here. So the contribution of this next part that is written here, this will be only x raised to the power 16. But there is a catch. If I write a general term in this, it can be written as 9cr and minus x raised to the power 3 raised to the power r. So you can see that the terms here can only occur in multiples of 3. X cube, then x raised to the power 6. So x raised to the power 16 will never happen. What we are saying is, because of this phenomena, the contribution of this second part becomes 0. So your answer becomes the one that we got from the first one, that is 84. So option A becomes correct. Now the next problem type is nothing but questions based on multinomial theorem. So now we can see that sometimes the questions will be given to us there wherein in the bracket, in the bracket we will have more than two terms. So if there are two terms, we can apply binomial theorem. But let us say if the terms are more like a1 plus a2 plus a3 till am, and the power is n. Now, how to write the expansion of this? This theorem is known as multinomial theorem. So, in order to write this expansion, the general term that we are going to write in this case will happen in this manner. So, if I write n factorial, it will be divided by n1 factorial, n2 factorial till nm factorial. Now, what are these n1, n2, n3, nm? These are nothing but the powers of a1, a2, so on and so forth till an. So what we are saying is, like, we have a1 plus a2 raised to the power n. In this case, a general terms look like this: ncr a1 raised to the power n minus r and a2 raised to the power r. In this case, the general term is going to look like this. Now, the proof of this theorem is not in your syllabus, and all the questions that we are going to see using this method can be solved using some other method also. But this method will make our solution smarter, smaller, and more accurate. So that is the reason we are doing it. Now let us take an example and understand how this works out. So let us say that if I have to find the expansion of x plus y plus z raised to the power 3, what I am going to do is, I am saying the general term is going to look something like this: 3 factorial divided by n1 factorial, n2 factorial, and n3 factorial, wherein x raised to the power n1 will come, y raised to the power n2 will come, and z raised to the power n3 will come. So now you can see that how many terms will be there. So now you can see we can start with terms like where I can put the value of n1 as 3. Then in that scenario, n2 will become 0 and n3 will also become 0. Now why is this happening? Because whenever we are writing this, the sum of n1, n2, n3 always needs to be equal to 3. Similarly, in the case earlier that we discussed, n1 plus n2 plus n3 plus nm. In this earlier case, if I write n1 plus n2 plus n3 till nm, it needs to be equal to 1. This is known as multinomial theorem. Now, corresponding to this, you will see that you will get one term, that is 3 factorial by 3 factorial into 0 factorial into 0 factorial. X raised to the power 3, y raised to the power 0, z raised to the power 0. This is what we are writing. In this manner, if you keep putting values of n1, n2, n3, you will get the whole expansion. But nobody here is going to ask you the whole expansion. The point of this question is to find some specific power of x. Now let us see how this is useful in solving questions. So if I take this question of 2023, what we need to do is basically in this expansion, they are asking what is the coefficient of x raised to the power 7. So how to attempt such question? First step would be to write the general term. So if I write the general term, it works something like this: 10 factorial divide by nothing but n1 factorial, because there are 3 terms, n2 factorial, n3 factorial, wherein n1 is nothing but the power of 1, n2 is nothing the power of minus x, and n3 is nothing but the power of 2x cube. And we already told that the condition was that n1 plus n2 plus n3 should be equal to 10 or the power. The second step is, if I simplify this, what I'm getting is nothing but 10 factorial by n1 factorial is fine, n2 factorial is also fine, n3 factorial is also fine. In the coefficient part, we will also get something as minus 1 raised to the power n2 and 2 raised to the power n3. And all the powers will get added in the power of x, and this will become twice of n3 plus n2. Now in these questions, it is very important, since we want to figure out the coefficient of x raised to the power 7, this power that we have written here, this power will become nothing but equal to 7. And also we know that in this case, n1, n2 and n3 are nothing but whole numbers. So they need to follow 2 conditions now. One is this condition which is given in the question, and one is the default condition. Now once we have these 2 conditions, using these 2 conditions, what we are going to do in the next step, we are going to make a small table and see how many terms will be there which satisfy these 2 conditions, because those terms are going to contribute x raised to the power 7. So if I do that, what you can see here is, let us start with the maximum value of n3 that can be there. So that value is nothing but 3. In that case, n2 will become 1. Now n1 plus n2 plus n3 needs to be equal to 10. So n1 will become 6. If I put here 2, it becomes nothing but 3, and then this becomes 5. If I put here 1, in that scenario, you can see that your n2 becomes 5 and this becomes nothing but 4. And if I put here 0 in the last case, you can see in this case n2 will become 7 and n1 will become nothing but 3. So in this way we can get different cases. In each of these cases, if you take, the power of x will come out to be 7. So in this cases, if I just write the coefficient in the fourth step, what I'm doing is I'm writing the coefficients in each of these cases. So if I do in the first case, my coefficient becomes 10 factorial by 6 factorial into 1 factorial into 3 factorial into minus 1 raised to the power n2 and 2 raised to the power n3, that is nothing but 3. In the next case, if I try and write it down, you can see that this comes out to be 10 factorial by 5 factorial into 3 factorial into 2 factorial minus 1 raised to the power 3 and 2 raised to the power 2. And in the last one, third one, if I try and write it down, then 10 factorial by 4 factorial into 5 factorial into 1 factorial minus 1 raised to the power 5 and 2 raised to the power nothing but n3, that is 1. And in the last one, if I try and write it down, it comes out to be nothing but 10 factorial by 3 factorial into 7 factorial into 0 factorial into minus 1 raised to the power 7 and 2 raised to the power 0. Now our job is very simple. After this, we need to add them down. If I add all of these down, I will get my answer, that is equal to 960. So in such questions, there are 4 steps to be taken. Now first step is nothing but writing the general term. The next step is to find the power of x, put it equal to the quantity that is given in the question. n1 plus n2 plus n3 will be equal to the power that is given in the question. Once you have written this case, in the third step you need to write the cases, find the value of n1, n2, n3 satisfying these 3 conditions. And it is always a good idea to start from the highest power of n3 that will satisfy. Then once you have done this, in the fourth step, write down the coefficient, add them down and get to the answer. Now if I look into this question that came in 2020, what you can observe in this question is there are 3 steps in which we can apply our multinomial theorem and get to the answer. So the first step is to write the general term. If I write the general term, that in this case becomes 10 factorial by n1 factorial, n2 factorial, n3 factorial, 1 raised to the power n1, x raised to the power n2, and x square raised to the power n3. And the condition here is n1 plus n2 plus n3 should be equal to 10. And if I simplify this up, it looks like 10 factorial by n1 factorial, n2 factorial, n3 factorial. And the power of x will here come out to be n2 plus 2 times n3. In the next step, we have 2 conditions. One we have already written, n1 plus n2 plus n3 is equal to 10. And another that is given in the question, that the power of x, because they want us to tell the coefficient of x is to the power 4. So the value of the power n2 plus 2 times n3 needs to be equal to 4. In the third step, based on this condition, let us draw a simple table in n1, n2 and n3 and figure out what can be the possible values based on the above conditions given. So if I draw this table, what you can observe is, let us start with the highest possible value of n3 that might be possible in this case. And that value can be nothing but 2, because n1, n2, n3 needs to be whole number. These are nothing but whole numbers. So minimum value can be 0 and it can go up till 10. So if I look into this question, what you can observe here is, if I put n3 is equal to 2, corresponding to this n2 becomes 0. And since n1 plus n2 plus n3 is equal to 10, this value will become 8. Again, another value is 1 and then 0. If I put 1, you can see that this will become 2. And corresponding to this, n1 becomes 7, then 0, 4 and 6. So you can see that we have got 3 different cases. Let us calculate the value corresponding to 3 different cases in step number 4. If I calculate the first one, it is nothing but 10 factorial by 8 factorial into 0 factorial into 2 factorial. And if you simplify this, it is 10 into 9 by 2, it comes out to be 45. If I take my next scenario or my next case, you can observe that this is 10 factorial by 7 factorial into 2 factorial into 1 factorial. So it is 10 into 9 into 8 divided by 2. So you can see that this becomes 4 and this is nothing but 360. And if I move towards the last one, again I can simplify this and write it as nothing but 10 factorial by 6 factorial into 4 factorial into 0 factorial. So it is 10 into 9 into 8 into 7 divided by nothing but 4 into 3 into 2. 4 into 2, 8 we can cancel out. And now you can see that this comes out to be 210. And now if you add all of them up, the answer that we get is 615. So you can see in every question that we are going to solve on this idea of multinomial theorem, there are going to be 4 steps. First, write the general term, get the value of coefficient of x, n1 plus n2 plus n3 should be equal to the power. Once you have done that, make your cases, get answer to corresponding to all of those cases, add them and get to the answer. Now let us look into a question based on this idea. So what we can do here is, there are 3 simple steps. In the first step, let us write the general term. So that is going to be nothing but 10 factorial by n1 factorial, n2 factorial and n3 factorial. 1 raised to the power n1 minus x raised to the power n2 and 2x cube raised to the power n3. And if I simplify this, this is 10 factorial by n1 factorial, n2 factorial, n3 factorial minus 1 raised to the power n2 and 2 raised to the power n3. And if I write the power of x, because that is the most important part, because what we want is coefficient of x is to the power 7. So this becomes nothing but 3 times n3 plus n2. Once you have got this, first you need to focus on 2 important ideas. One, we know that n1 plus n2 plus n3 in any case will be equal to the power, that is 10 here. And the second important condition here is, if I write 3 times n3 plus n2 in the question, since they have talked about power of 7, we'll equate this to 7. So this is something that we are doing in this question and will change from question to question. Once you have done that, in the third step, make a small table writing n1, n2, n3 and see what possible cases of n1, n2, n3 are possible based on these 2 conditions. Also, we know here that n1, n2 and n3 are nothing but whole numbers. Once you have done that, now let us put the value of n3 here. So the maximum value of n3 that is possible is 2. Then we can also put 1, then 0. If I start with 2, corresponding to that, the value of n2 becomes 1. And since n1 plus n2 plus n3 is equal to 10, n1 becomes 7. Similarly, if I put 1 in n3, my n2 will become nothing but 4. And corresponding to that, my n1 will become nothing but 5. If I put 0, this becomes 7 and this becomes 3. You can see we have 3 distinct cases in which the power of x would be equal to 7. Now let us try and calculate the coefficient of all those 3 cases. In the first case, my coefficient becomes nothing but 10 factorial by 7 factorial into 1 factorial into 2 factorial minus 1 raised to the power 1 and 2 raised to the power 2. In the next case, what we are getting is nothing but 10 factorial divided by 5 factorial into 4 factorial into 1 factorial minus 1 raised to the power n2 and 2 raised to the power n3. And in the last case, what we are getting is nothing but 10 factorial divided by 3 factorial into 7 factorial into 0 factorial minus 1 raised to the power 7 into 2 raised to the power 0. Now, what we will do is we'll find these values. This is not very difficult to calculate. If you calculate and add them, what you get is 960. I have done the calculation. You can also try and do it. You will get the answer. So there are 3 important parts in this question. First, write the general term. In that, always remember n1 plus n2 plus n3 will be equal to the power. Second important thing is, whatever is the value of x power that is given in the question, equate that to the power of x in our general term. Based on these 2 conditions, make a small table like I have done. Find the coefficients in each of these cases, add them and get the answer. Now let us look into this next question based on a similar kind of idea. In this, what they are asking is term independent of x. Now this is the same question and the button steroids. So what they are doing in this question is, they are asking the same question of x is to the power 0 when it can arise, but in context of a trinomial. So we'll have to apply multinomial theorem to solve it. So the first step, as I told earlier, is to write the general term. So if I write it out, it will become 5 factorial by n1 factorial, n2 factorial, n3 factorial. This will become twice of x raised to the power n1, 1 by x raised to the power 7 raised to the power n2, and 3x square raised to the power n3. Also, we know that n1 plus n2 plus n3 is equal to 5. And your n1, n2 and n3 are nothing but whole numbers. So you can see that the value of n1, n2, n3 can lie between 0 and 5. 0, 1, 2, 3, 4, 5. These values they can take. Now if I move forward, and simplify this, it becomes 5 factorial by n1 factorial, that is fine, n2 factorial, n3 factorial is also fine. We'll get 2 raised to the power n1 and then 3 raised to the power n3. And in the power of x, and this is very important, what we are getting is nothing but n1 minus 7n2 and plus 2n3. This is what we are getting in the power of x. And now why this power of x is important? Because in the next one, we'll write the basic conditions. So obviously the first condition is n1, n2 and n3 is equal to 5. And the next condition that we have written from here is n1 minus 7n2 plus 2n3. This is equal to nothing but 0 because we want the term independent of x or the constant term. So in order to solve this further, it is always better to have equation in terms of two variables. So let us eliminate n1 using these two conditions. So if I do so, if I subtract from the first equation, second equation, what I get is nothing but 8 times n2 minus n3 will be equal to 5. Or in simple language, 8 times n2 is equal to n3 plus 5. Right. Now in the third part, what we are going to do is we are going to develop the table between n1, n2, n3 and figure out what are the possible cases and then write the coefficient based on that. So once we have written that, now the first, let us start with the values of n3. So what will happen if I put the value of n3 as 5, then 4, then 3, then 2, then 1 and then 0. So if I put it 5, then 5 plus 5 becomes 10. Now here you can see that if I put this, and I will show you by putting, because there is something very important I want to illustrate. So if I do this in the first case, corresponding to this, you can see that the value of n2 is not coming out to be a whole number. So this case is not possible. So though we wrote this case, but this value of n3 will never come. Now let us try for the next case. So in the next one, if I do the same thing, instead of 5, what I will do is I will put here the value of n3 as 4. Now again you can see this becomes 9 and even this is not possible. So this value is also not possible. If I put 3, now this is possible because if I put 3 here, then it becomes 8 and corresponding to this n1 will become 1. So this is 1 and this will become 2. You can see that if I put instead of this 2, 3, if I put 2, let us see what value we get. If I put 2 again, the n2 is becoming 7 by 8. It is not a whole number. Hence this third case is also not possible. Similar we can observe for the other cases, they are also not possible. So you can see that after doing this much calculation, what you can observe here is only one relevant case is there, and that is nothing but 2, 1 and 3 values. Now our job is very simple. All we need to do is do this calculation and come up with the answer in the fourth place. So what is our coefficient? 5 factorial by 2 factorial into 1 factorial into 3 factorial. And in the power of 2, we will have n1. In the power of 3, we will have n3. And if I simplify this, what we get is 1080. And that comes up to your answer. In this next problem type, that is problem type number 9, we are going to see questions based on ratio of terms. Now, whenever we have to find ratio of terms, there is this formula that is very important, that is NCR by NCR minus 1. So if you apply this formula, the result is nothing but n minus r plus 1 by r. Now, this formula will help you reduce a lot of calculation while you are solving problems. And JEE has asked numerous such questions in their exams. So let us see what kind of questions JEE asked and how to solve them. In this 2023 question, what they are writing is 2nc3 by nc3 is given as 10:1. Then they are asking us to find some ratio of two terms. So now if I look into this, you cannot apply the formula because it is not in the form of NCR divided by NCR minus 1. So if you cannot apply the formula, go to the derivation of the formula. So if I write the value of 2nc3, it can be written as 2n into 2n minus 1 into 2n minus 2 divided by 3 factorial. And if I write the value of nc3, it can be written as n into n minus 1 into n minus 2 by 3 factorial. Now if I divide them, what will I get is nothing but 2nc3 divided by nc3. And you can see 3 factorial will get cancelled out. So 2n into 2n minus 1 into 2n minus 2 divided by n into n minus 1 into n minus 2. Now if you simplify, this n will get cancelled out. N minus 1 will get cancelled out. And we have been given the value of this expression as nothing but 10:1. Now let us cross multiply and get the value of n. So if I cross multiply, what I am getting is 4 into 2n minus 1 would be equal to nothing but 10n minus 20. If I simplify, this is nothing but 8n minus 4 is equal to 10n minus 20. And if I take terms on the other side, this is nothing but 16. And that will become nothing but 2n. So the value of n from here comes out to be 8. Once you have got the value of n as 8, the next step is to put it in the expression given in the question and get its value. So if I put it, it is nothing but 64 plus 24 divided by 64 minus 24 plus 4. And if I simplify this, what am I getting is nothing but 88 in the numerator. And if I simplify this, 44 in the denominator, and the answer comes out to be 2. That is nothing but option P. So quite a simple question based on the derivation of the formula that we earlier talked about. Now this is a very typical question that comes from NCERT. In this question, what we need to do is we need to find the ratio of these three terms. And from there get the value of n. Once we have got the value of n and x, what we need to find is the fourth term. Now this question is there is also in the NCERT. So NCERT based question was asked in JEE means 2023. So if I write any three consecutive terms, they can be written as NCR, coefficients we are writing, NCR plus 1 and NCR plus 2. So these are three consecutive terms, coefficient. So they are talking about coefficient. Now what they are saying is their ratio. So if I divide NCR plus 1 by NCR, it is given as nothing but 5:1. And if I simplify this, so now our formula was, again let us go back to the formula and revise it. NCR by NCR minus 1 was equal to n minus r plus 1 by n. So if I apply this formula, this is n minus r plus 1 by r. And if I simplify this, the relation that I get is n minus r is equal to 5r plus 5. And n is nothing but 6r plus 5. Okay. This is the first equation. Now, if I do the same thing one more time, so what we have is NCR plus 2 by NCR plus 1. This, if I write, is nothing but 20 by 5 will come out to be 4. And if I simplify this, it comes out to be n minus r plus 1 by r. And again, I can simplify this. And if I simplify this, the value of n minus r minus 1 would be equal to 4r plus 8. And if I simplify this, it comes out to be nothing but n is equal to 5r plus 9. Now what we can do is we can solve both of these and find the value of n. So if I do so, the value of n, and if I equate them, what we are getting is 5r plus 9 will be equal to 6r plus 5. If I simplify, the value of r comes out to be equal to 4. And if I put this in any of this equation, let us say the next one, the value of n is nothing but 5 into 4 plus 9. So n comes out to be 29. So this is first part of the question where we need to find the value of n. In the second part of the same question, what we need to find is the coefficient of the fourth term. The coefficient of the fourth term, if you are writing, would be nothing but NC3. Because fourth term NCR plus 1, if you write, it comes out to be NC3. Now the value of n is also known, that is nothing but 29C3. So if I write it down, this is 29 into 28 into 27 by 3 into 2. And if I further simplify it, this 3 if I cancel out, this terms becomes 9, and 2 if I cancel out, this terms becomes nothing but 14. And if I multiply them, I get my answer is nothing but 3654. That is nothing but option A. Now let us move on to this next question that again came in 2023. In this question, what they are saying is, and they are trying to needlessly complicate the question by writing this kind of statement. What they are writing is AR is the coefficient of x raised to the power 10 minus r. See, if this in this binomial expansion, if I write a general term, it is 10CR into x raised to the power r. Okay, so if I am writing in place of r 10 minus r, here in place of r also 10 minus r will come. So they are saying that this is the value of AR. So here AR is nothing but 10C 10 minus r. And now using the property, this can also be written as NC n minus r or 10CR. Okay, so they have needlessly complicated it, but the fundamental thing that you need to know, the first part is the value of AR is nothing but 10 CR. In the next part, what we need to do is we need to simplify what is written in the bracket, that is AR by AR minus 1. So if I write this, we have a general formula. So this becomes 10 CR by 10 CR minus 1. So n minus R plus 1 by R. This is what we are getting. But now what they are saying is, let us also multiply a R cube and put a summation sign from R is equal to 1 to 10. So if I do that, this becomes nothing but 11 minus R whole square by nothing but R square. And if you simplify this R square will get cancelled out, 1 R will remain. And now this is quite simple, because if you expand it, this becomes R into 11 minus R whole square. So if I open the bracket, it is R square minus 22R plus 121. And again, if I open the bracket, what I get is summation of R cube will happen, then 22R square plus 121R is there. If I put all the relevant values here, let us see what will I get. So if I put all the relevant values, what happens here is summation of R cube. This can be written as n into n plus 1 by 2 whole square. Now this is what we can write in the place. The same thing, if I put another value R equal to 1 to 10 R square, it is n into n plus 1 into 2n plus 1 by 6. Now this also we can write. And then what we have is got the last thing, that is summation of R is equal to 1 to 10 R, and that we can replace by n into n plus 1 by 2. And if you put this value and simplify this, what you get is the value of 1 to 1. See, now this was asked in 2023. I don't think this can be asked this year, because this all summation based formula are now out of syllabus. But still you should know the concept, because the same concept can be asked in different manner. Now if I look into this next question, it has a lot of small parts. Like if I first understand this expansion and if I simplify this, so they are using this ABC formula. Now what is ABC formula in log? So A log C to the base B can be written as C log B to the base A. And there is a shortcut. Sometimes what happens is, instead of writing this, they will write like this. So if you do this, if you use your ABC formula, this will become A to the base A and this will become equal to C. Now this concept of log is being used. So there are multiple things mixed up in this question, and that makes this question really interesting. So this is one thing. So now this has been used multiple times. So if I look into this part that is written inside it, I can apply it here, and you can see that this becomes 10 minus 3 raised to the power x raised to the power 1 by 2. And if I again apply it here, and I can simplify this part and write 2 raised to the power x minus 2 log of 3 to the base 2. So we can write this as log of 2, 3 raised to the power x minus 2. So this becomes nothing but 3 raised to the power x minus 2. Okay, so you can see that this idea is being used multiple times. And if I apply this, the second part in my expansion becomes 3 raised to the power x by 2. And then there is a fifth power, so divide by 5 raised to the power n. So once you observe this much, you will be able to see how this expression is getting simplified. Once you have observed that, let us delete this part, all this calculation based on log. This was the first part of the question using this property. Now let us move on to the second part. Now what they are saying is, in the increasing powers of this part, now what is this? Again, you apply that ABC formula and you will realize that this is nothing but 3 raised to the power x minus 2 once more written. So in this way, cryptically they have written the same thing again and again. So what they are saying is, if I write the sixth term, so sixth term T6, it is going to be nothing but MC5 10 minus 3x raised to the power 1 by 2 and raised to the power m minus 5 into 3 raised to the power x minus 2 by 5 raised to the power 5. And the value of this is nothing but 21. What they say, sixth term in binomial expansion is given as 21. So this is the second part. And then they talk about a third part in the question. Third part talks about that if you write binomial coefficients of second, third and fourth term. So if I write second term, corresponding to them, the binomial coefficient would be nothing but MC1. For third term, it will be MC2, and for the fourth term, it is going to be MC3. Now these are nothing but first, what they write, this is nothing but the first, that is a, third, that is a plus 2d, and fifth, that is a plus 4d in an arithmetic progression. These are in AP like this. So you can see that there are three very important concepts: log, then binomial expansion, and then AM getting intermixed in one question, and that is the beauty of this question. Now this much you should know theoretically in order to conceptualize this question. Now after this the calculation starts. So our idea would be, our strategy would be here to somehow get the value of m from here. We can use this value of m here and get the values of x, because now there is a fourth part waiting that says that if you square all the possible values of x, what is the answer? Okay, so let us move to the calculation part now. So if I calculate this, if I subtract mc2 minus mc1, this is going to be 2d, and also if I subtract mc3 minus mc2, it is again going to be 2d. Now in order to solve this, you can simplify by dividing this by mc2. So this becomes 1 minus mc1 by mc2, and this becomes mc3 by mc2 minus 1. And what is the advantage of doing this? So if you do this, this becomes, you can apply your formula m minus r plus 1 by r, and here also m minus r plus 1 by r minus 1. So you can see your calculation becomes simpler by using that Shival formula, because already there is so much complexity in the question. It does not make any sense to make it more complex by directly doing it. So if I do this, what I get is m minus 2 by m minus 1 is equal to m minus 2 by 3 minus 1. And if I cross multiply and simplify, this becomes m minus 3 by m minus 1 is equal to m minus 5 by 3. So let us simplify this further and see what do we get. If I simplify this, what I get is 3m minus 9. This would be equal to m square minus 6m plus 5. And if I simplify this, this is nothing but m square minus 9m plus 14 equal to 0. So you can see that there are two values of m possible, 7 and 2. But since they have already talked about a fourth term, a third term, so definitely m cannot be equal to 2, m needs to be equal to 7. So you can see that from here, by solving this third part, we have got the value of m as 7. Now let us put this value into this first equation or the first part of the question, and let us get the value of x. So now if I solve this in the next part and put values here, this becomes 7c5, 10 minus 3x, m minus 5 will become 2 by 2, and this becomes 3 raised to the power x minus 2 by 5 raised to the power 5 equal to 21. Now if once I start solving this, you can see that this part can be written as 7 into 6 by 2. This part can be written as 10 minus 3x. And here if you simplify, it is 3 raised to the power x minus 2 equal to 21. 7 again I can cancel out. This becomes 3. 3 also I can cancel out. This becomes 2. 2 will also get cancelled out. So what am I getting? Here is nothing but 10 minus 3 raised to the power x into 3 raised to the power x by 3 square equal to 1. And again, if I take 3 raised to the power x as t, then this will become 10 minus t is equal to t. This 3 square, 9 we can take on the other side. You can see what we are getting is 10t minus t square is equal to 9. And again, if I simplify this, this becomes t square minus 10t plus 9 is equal to 0. So we are getting two values of t here, 1 and 9. So corresponding to that, 3 raised to the power x will be equal to 1 and 9. And corresponding to that, the value of x comes out to be 0 and 2. Now see, they are not asking 0 plus 2. What they are asking in the fourth part is nothing but square of these values. So our answer is 0 square plus 2 square, henceforth. You can see that this is a highly complicated question in the sense that there are multiple things getting mixed up. There is the property of log. After that, you also need to know binomial expansion. Then after that, you also need to know AP. And after that, you need to solve and then solve an exponential equation and come up with an answer. So multiple things getting mixed up. Beautiful question. Now let us move to next problem type, that is divisibility. And this problem type have been asked in multiple papers, and very beautifully questions have been framed on this idea. Now let us see how do we solve questions based on divisibility. So there are these 5 important results that you need to know. The first is if you have 1 plus x raised to the power, I will take an example and explain you, raised to the power 10. Then once you start expanding it, what will happen is first term will become 1, then 10c1x, then 10c2x square, so on and so forth. So you can write this as 1 plus x into an integer that can be written as 1 plus mx. So that is what our first result is saying. Got it? Next result, what we are saying is in this power, if I write an even number, even in case of minus sign, I can use the same statement. By expansion, again, you can realize this result. Next one, what we are writing is if we have an odd power here, then instead of plus 1, you will get minus 1 here. For example, if I write 1 minus x raised to the power 11, then once I start simplifying, what we will observe is what we are getting is nothing but minus 1 plus mx. More appropriate way of writing this would be nothing but instead of this, we could have written this as x minus 1, would have made much more sense. This is much simpler way of writing the same result. So instead of writing it here, let us write this as x minus 1. In the next one, what they are saying is nothing but if we have something like 9 raised to the power 4 minus 5 raised to the power 4, then this is definitely going to be a multiple of 9 minus 5. So this is going to be a multiple of 4. This is a very interesting idea. And the last one says that here we have been doing for negative sign. So any value of n is fine, either even or odd. But if you want to apply this for positive sign, like 9 raised to the power 4 plus 5 raised to the power 4, for this we have no result. But we have 9 raised to the power 5 plus 5 raised to the power 5. Then this is also a multiple of 9 plus 5. Now these 4 results we are going to use in order to solve problems. Now let us start with this first question based on divisibility. Now the trick in solving this question is, when they are saying fractional part, what they essentially mean by this fractional part is, what is the remainder when 4022 is divided by 15? Now that remainder by 15 is nothing but the fractional part. So this is what you need to understand, and this is the fundamentally question based on remainder. Now, once you have understood this first thing, now let us move on to the second idea. Now the second thing is, what we need to do is we need to search for some power of 4 such that it is 1 plus minus the divisor. So here if I take 16, it is equal to 1 plus 15. Why are we doing this? Because in the third step, when you will write 4 raised to the power 2022, we will be able to express this as 4 square raised to the power 1011. That in turn can be written as 1 plus 15 raised to the power 1011. Now in the starting, I have told you very important property that if you have 1 plus x raised to the power n, it can be written as 1 plus mx. We can apply this property and write 4 raised to the power 2022 as nothing but 1 plus 15 into some m integer. Now once we are able to do this, the greatest advantage of doing this is now you can clearly see that from Euler's division lemma that 4 raised to the power 2022 can be expressed as 15 into something plus 1. So 1 becomes our remainder. So in the fourth part, you can see that 1 is the remainder. So the fractional part from here can be written as 1 by 50. So your option C is the correct answer. Now again, similar kind of question was again asked in 2020. So in 2023, the same question got repeated. Again, if you see, what we need to figure out is what is the remainder. So what is the remainder if 3 raised to the power 200 is divided by 8? That is what we want to answer. And if they want the fraction, we'll divide that by 8. The second part will think of a power that is closer to it. So 3 square is 9 and it can be written as 1 plus 8. The third step, 3 raised to the power 200 can be written as nothing but 3 square raised to the power 100. So in the next step, I will be able to write this 9 raised to the power 200, 9 raised to the power 100 as nothing but 1 plus 8 raised to the power 100, which can in turn be written as 1 plus m times 8. So from here, you can clearly see the remainder is 1. So the fractional part becomes 1 by 8. That is nothing but option B. Now this is the better question that was asked in 2023 and it attacks the core of the formula that we derived earlier. So here we'll have to apply a little bit of binomial expansion. So if what I can do is I can write this 2023 as nothing but 289 into 7. So what I can do is I can write this as 289 as 290 minus 1 into 7. So in turn, this can be written as nothing but 290 into 7 minus 7. Now, why is this important? Because 290 can be written as 229 into 2 into 5 into 7 minus 7. You can see that out of this I can get a 35. It is nothing but 35n minus 7. Now, this is very important because we were able to extract a 35 out of it. Now, once you do this in the first step, in the next step, what we want is, if I put a power 2023 over it. So if I write the binomial expansion, what we will observe is, if I write it 2023 C0 35n raised to the power 2023 will come. And we can write all the terms. The second last term is 2021 23 C2021 35n into 7 raised to the power 2022. And the last term is going to be nothing but minus 7 times 2023. Now the interesting thing is, each of these numbers have a 35 into it. So this is the multiple of 35. So now if I simplify it, it can be written as 35 times some n, and what you are getting is 7 raised to the power 2023. That can be written as 7 into 7 raised to the power 2022. So 35m minus 7, and here 7 square can again be written as nothing but 49. So if I write this, this is 35m minus 7 times, this also becomes 49 times 1011, and which can be in turn written as 35m minus, and this can be written as 50 minus 1 raised to the power 1011. Now again I can rewrite this expression as nothing but 35m minus, again if I open it and you can see the power is odd, I will be able to write this 15 times m1 and some other constant minus 1. And this was another property that we did. So if I multiply this, you are getting 35m here. This can be written as 35 into 10m1. And then the last term will be nothing but plus 7. So you can see that all of this has a 35 in it. This term is independent of 35 and hence will become the remainder, that is 7. Now this is a more interesting question than the last one because there are two terms involved. Earlier there was only one term involved. If I look into this question, what I can do is the first part can be written as 21 minus 2 raised to the power 200 and 21 plus 2 raised to the power 200. Now why we have chosen 21? Because it is 3 into 7. So factor of 7 will come. And if I write binomial expansion, the factor of 7 will keep on increasing its power and will get 49 as a multiple. So this is the thinking process behind this. So once I do it, let me write my binomial expansion. So since you can see only difference between them is this plus and minus sign, so alternate terms will get cancelled out, and what we get is 200 C naught 21 raised to the power 200, 200 C 2 21 raised to the power 198 into 2 square. It will keep on going like this, and you will see the second last term will be 200 C 198 into 21 whole square into 2 raised to the power 198, and then the last term will be 200 C 200 2 raised to the power 200. Now the interesting part is, if I take terms from here to here, we can see that a 21 square is coming. 21 is nothing but 3 into 7. So 7 square is also there. So these all terms are divisible by 49. Now once you have observed that, so you can see that this is nothing but can be written as 49 into some m, and 2 into 200 C 200 can be written as 1, and this can also be written as 200. So whatever remainder we are going to get, that is going to come from this part. So let us now examine this part. So this was my first step. Let us move on to the second step. Let us see what we can do. So in this next step, I can write this as 2 raised to the power 201. 201 can be written as 2 raised to the power 3 raised to the power, and this if I divide by 3 becomes 3 into 6 and then 21 7. This is what we will get. And 2 raised to the power 3 can be written as 8, which in turn can be written as 7. So this is what we are getting. And if I expand this, what I'm going to get is 67 C0, 67 C1 into 7, 67 C2 into 7 square, so on and so forth. So from this term onwards, you can see that you have a consistent power of 7 square. And this will become a multiple of 49. So whatever remainder we'll get from this first part. So let us examine this further. So if I simplify this, it is nothing but 1 plus 67 into 7. And if I simplify this, this comes out to be 1 plus, can be written as 63 plus 4 into 7. And you can see what we are getting is, one part will be 63 into 7. Now this already has 7 square into it. What we have is 4 into 7 plus 1. And you can see that this will become a remainder. So this is nothing but 29. Let us again go back to the question. So if I look into the question, what I have done first is 19 is written as 21 minus 2 because 21 is a multiple of 7. And then 21 plus 2 for 23 raised to the power 200. We have applied the binomial expansion. And we can see that only in the last term, it will not have a component of 7 square. So we have taken them and we are trying to understand what will be the remainder contribution from there. So if I take down that one, you can see that it can be written as 2 raised to the power 3 raised to the power 67. 2 raised to the power 3 can in turn be written as 1 plus 7. We can write its binomial expansion and you can see that after second power onwards, 49's multiple will come. So remainder will come from the first two terms, that is 1 plus 67 into 7. 67 can in turn be broken down into 63 plus 4. Why 63? Because again it is a multiple of 7. So 7 square will come if 63 and 7 got multiplied. And then 4 into 7 plus 1 will become remainder, that is nothing but 29. Now if I move on to this next question, it is very interesting because again we get to use the properties. So what they're saying is first you find the remainder after dividing by 3, that is nothing but alpha. So let us see for 3 first. So for 3, 22 can be written as 21 plus 1 raised to the power 2022. And this second part is nothing but a multiple of 3. So we can write this as 3m raised to the power 22. So this is already a multiple of 3. So from here the remainder is 0. And this if I expand, I will be able to write this as 1 plus 21 times m dash. So you can see that from here also this number is a multiple of 3. The remainder comes out to be 1. So from the first term the remainder is coming out to be 1, the second term 0. So the value of alpha after adding both of them is nothing but 1. This is the first part. Now the second part of the question says that in order to find the value of beta, we'll have to divide by 7. So again, for finding the remainder from 7, what we can do is the first part, it is again can be written as 1 plus 21 raised to the power 2022. And the next one, we can write this will become nothing but if I divide by 7 minus 1. So this is how we can write this up. So if I simplify this, now you can see that this can be in turn written as nothing but 21 times m plus 1. And this can also be written as something like 7m into some m dash plus 1. Why plus 1? Because here the power is even. So this minus sign will have no impact. You can see that from this first part also, the remainder is coming out to be 1. From the second part also the remainder is coming out to be 1. So the total value of the remainder comes out to be 2. So value of beta becomes 2. If we want alpha square plus beta square, it becomes 1 square plus 2 square comes out to be 5. And let us see how we can do it. So again, this question is specifically based on this property a raised to the power n minus b raised to the power n will be a multiple of a minus b into n. So let us see how to apply this property in this question. So if I first take first and third term and second and fourth term, and if I write 25 raised to the power 190 minus 8 raised to the power 190 and minus sign 19 raised to the power 190 minus 2 raised to the power 190. From the first two terms, what I can write is nothing but this is going to be a multiple of 25 minus 8 times m1. And the next would be a multiple of 19 minus 2 times m2. So if I write it in this manner, what you are getting from the first one is 17 times m1 And second also becomes 17 times m2. 17 we can take common, it becomes m1 minus m2. So what you can see is this expression that is given to us is a multiple of 17. 17 is definitely there. Second, what we can do is I can combine first term and second term and third term and fourth term. If I do it in this manner, so it becomes 25 raised to the power 190 minus 19 raised to the power 190. And then minus sign I can take common. 8 raised to the power 190 minus 2 raised to the power 190. So if I write it in this manner, again, the first will be a multiple of 25 minus 19 into m3. And the next I can write at minus 2 into m4. So again, you can see that here from the first one, it becomes 6 times m3. Second also becomes 6 times m4. So we can say that this is a multiple of 6. So what you're getting from here is very simple idea that the given expression is multiple of two terms. One is 17 and another one is 6. 6 can be written as 2 into 3. So if you have this much, now if I look into the options, they are talking about divisibility by 14 and 34. See, 34 is possible if I take 17 into 2. So 34 is definitely there is no problem. But 7 is not possible because any of our factors that are coming will not make 7. So option D becomes correct, that multiple of 34 but not 14. If I look into this next question, what it talks about is two statements are given. In the first statement, again, the same properties, x raised to the power n minus y raised to the power n is a multiple of x minus y into m. We can apply the same property. So here you can see that this is 2023 minus 1999. This will be a multiple of this part. And if I write that, you can see that it will become a multiple of 24. So if it is a multiple of 24, obviously it will be divisible by 8. So this first statement is correct. So this one is true. There is no problem. Now move to the next part. What is given to me is 13 raised to the power n plus 1 minus 11n minus 13. What I can do is the first thing I can write this part as nothing but 1 plus 12 raised to the power n plus 1 minus 11n minus 13 and write its binomial expansion. So n plus 1 c0 plus 12 times n plus 1 c1 and then n plus 1 c2 12 square, so on and so forth. So all this would be a multiple of 12 square, and then what is written is 11n minus 13. If you look into these first two terms, this is exactly equal to this part, so they will cancel each other out, and what you are getting is 12 square I can take common from the remaining terms, to n plus 1 c2 plus n plus 1 c3 into 12, so on and so forth. Now this is an NCERT level question, so this becomes 144 times m. So you can see that it is a multiple of 144. So this statement is also true. Hence both statement S1 and S2 are correct. Option D becomes correct. Now if I look into another question that was asked in 23, what they are writing is the 50th root of x is 12. So what they are writing is x raised to the power 1 by 50 is equal to 12. That would imply x is nothing but 12 raised to the power 50. And the 50th root of y is nothing but 18. So that would imply y is nothing but 18 raised to the power 50. What they're asking next is if I write x plus y. So it would be nothing but 12 raised to the power 50 plus 18 raised to the power 50. So what will be the remainder if this is divided by 25? That is what the question is. Now, what you can do is in this question, we need to apply binomial expansion. Why? Because our property x raised to the power n y raised to the power n. This is only valid when n is odd. That would mean here you need to have an odd number like 2n plus 1. And here also an odd number like 2n plus 1. Only then you can write that this is a multiple of x plus y into n. Otherwise, you cannot apply this property. So this property is not applicable in this case since the powers are even in nature. We cannot apply it, hence answer cannot be 0. So what we need to do here is we need to write binomial expansion, go one step before. So what we can write this as is 15 minus 3 raised to the power 50. And the next one I can write is 15 plus 3 raised to the power 50. And simplify. And now this similar kind of question we did earlier in this discussion. You can follow this discussion and come up with an answer. The answer of this question comes out to be 23. Now let us start with this next question. In this next question, what they're saying is if I sum this up, the first part is based on sum of a GP. So first what I need to do is apply the sum of GP. So it becomes A into R, that is 3 raised to the power 2022 minus 1 by 3 minus 1, because there are 2022 terms in this expansion. if I find this and then I divide this by 50, what is going to be my answer? What is going to be my remainder? That is what they're asking. So let us simplify this. So this becomes 1 by 2 times 3 raised to the power 2022 minus 1. Now, since I want to talk in terms of some half of 100, so it makes sense that I write this as 3 square raised to the power 1011 minus 1. And I can further write this down into 9 raised to the power 110 minus 1. And if I do that, what I can write this further as nothing but 10 minus 1 raised to the power 1011 minus 1. What is the benefit of doing this? Now that we are going to see in the consecutive steps. So if I do this, 1 by 2 is fine. Whatever is inside can be expanded and written as 1011 C0. So this will become 10 raised to the power 1011. Next, there will be a minus sign 1011 C1, 10 raised to the power 1010, and this will go on. But the last two terms are important. So last two terms will be 1011 C1010 into 10, and last one would be 1011 C1011. And then obviously there is this minus 1 from above. So if I do this, see, this last two terms are very important. Why these are two very important? Because the rest of the terms, if you look into this, they will always have a factor of 10 square. So if I divide by 2, it will become 50. So what I can write in the next step is this is nothing. And then if I simplify this, this becomes 1011 into 10 minus 2. Now if I bring this 1 by 2 inside, what is going to happen is in the first part it becomes 50m. In the second part it becomes 5055. And this becomes 1. So if I simplify this, so what I am getting is nothing but 50m. So this part is fine, taken care of. The rest of the part I can write is 5054. And now clearly you can see that if this part, if I divide by 50, the remainder will come out to be 4. Hence 4 becomes 1. Now, next category of problems is nothing but sum of coefficient. In this type of problem, you should remember 2-3 ideas. The first idea is, this is based on the concept of substitution, addition, and subtraction. Now, how do we apply these ideas? That is important because time and time again we are going to use this concept while solving such problems. So let us say that we have 1 plus x raised to the power n. So the expansion is going to be nc0 plus nc1x plus nc2x square till ncn x raised to the power n. So now here, if I substitute in place of x1, what I get is 2 raised to the power n is equal to nc0 plus nc1 plus nc2. The sum of binomial coefficient is equal to 2 raised to the power. Now instead of this, had I substituted the value of x as minus 1, I would have got 0 on the left hand side. nc0 minus nc1 plus nc2 minus nc3, so on and so forth. So from here, if you simplify, what you will get is the coefficient of even power terms is equal to coefficient of odd power terms, that is nc1 plus nc3, so on. And since both of these are equal, their sum is equal to 2n. If I put this, so let us say that this is equal to x, and if I put this in the first part, so 2 raised to the power n is equal to x plus y and x plus x. So the value of x or the series comes out to be 2 raised to the power n minus 1. Now this is very important. And one more, so this is what we are doing is substitution. This is the first idea. Now if I do substitution is in another way and then start adding my first series with it, I will get another kind of an idea. So if I, instead of this x, if I replace this x by minus x, let us see what happens. So what we get is 1 minus x raised to the power n is equal to nc0 minus nc1x plus nc2x square, so on and so forth. Now what I can do is I can take this as my equation 2 and add and subtract to equation 1. So if I add it, you can see that if I add, my odd power terms will get eliminated. And if I subtract them, 1 minus 2, in that scenario, what is going to happen is 1 plus x raised to the power n minus 1 minus x raised to the power n. My even power terms now will get eliminated. See, so we are playing with these three ideas. What we will be doing is writing the standard series and putting substitutions, writing the standard series and then adding and subtracting. So this is one very important idea that you should remember. There is a second very powerful idea on which problems are based is, sometimes let us say that they have given this expansion. They are given this term, let us say. And if I write it down, I don't know what will be the coefficient, but I definitely know if I write the expansion, this is how it is going to look. Highest power will come when this 100 and 2 will overlap, and this will become a raised to the power 200. So there are going to be 201 terms in this expansion. Now, if somebody is asking us in this scenario to find the sum of the coefficient, so whatever we learned earlier is still true. What we can do is we can put x equal to 1 here. If I put 1, this becomes nothing but 3 raised to the power 100. And what am I getting is a0 plus a1 plus a2 up till a200. And if I want to have alternate plus minus sign, I will put x equal to minus 1. And this becomes nothing but 1 minus 1 plus 1 raised to the power 100. And now a0 minus a1 plus a2 minus a3 up till a200 we can get. Now if you want just the even terms, we can take this first equation and second equation and add them up. So if I add 1 plus 2, what will happen is we are getting 3 raised to the power 100 plus 1. And now you can see the coefficient of only even power term will remain till a200. So from this you can get the sum of this. And if I subtract them 1 minus 2, then this is 3 raised to the power 100 minus 1. Now you will get 2 times only the coefficients of odd power terms. So this is an interesting idea, and we are going to time and time again use this idea to get results. So let us look into another question that was asked on similar idea. So what you can do in this question is, if I multiply these two series, what we are going to get as in multiplication is a series that has a0 plus a1x plus a2x square, and the last term will have power 4n. So this is what we are going to get. We do not know what is the value of a0, a1, a2, a3, an. Now what they want is the sum of the coefficients of even power of x. So ultimately what they want us to find is the value of nothing but a0 plus a2 plus a4 until a4n. So how to get the sum of these coefficients out of this? So the technique is very clear here. What we are going to do is, first we are going to put x equal to 1. If I put x equal to 1, the first series becomes 1 plus 1 plus 1 up till 2n. The second becomes 1 minus plus 1 up till 2n. And then this series will also become a0 plus a1 plus a2 up till a4. Once you have done this, what you can do is, in the same series, let us try and find its sum. So this becomes 2n plus 1. This will become 1. And that will be equal to a0 plus a1 up till a4. Next, what we can do is substitute x equal to minus 1 in the series above. So in this case, the first part becomes 1 minus 1 plus 1 minus 1, so on and so forth. And the second part becomes 1 plus 1 plus 1, so on and so forth. And if I write this out, it becomes a0 minus a1 plus a2 minus a3, so on and so forth. So now if you simplify this, it takes the same value, 1 into 2n plus 1. And this will be equal to a1 minus a2 plus a2 minus a3, so on and so forth. Now we had this first equation earlier. This is my second equation. What I can do is I can add both of these equations. So if I add 1 plus 2, what I'm going to get, on the right hand side it becomes 2n plus 1 plus 2n plus 1 on the left hand side. On the right, what we get is, now you can see that a1, a2, a1, a3 will get cancelled out, and we will get nothing but the coefficients of even power, that is a0 plus a4 up till a4. Now they have given the value of this as 61. So the value of this part is given as 61. If I put this value, this is 2 into 61. And this becomes 2 times 2n plus 1. So if I simplify this, the value of n comes out to be 30. which is nothing but our answer. Now this next question goes little bit more further in this approach. What we can do is we can write this expansion. So if I write it, you can see that if I add like we did earlier, two same kind of series, so it is of the form a plus b and this is of the form a minus b raised to the power 6. So what will happen is your odd power terms will get cancelled out. And what you are going to get as a result, if I simplify this, is 2 times the even power terms. What does that mean is what we are going to get is 6c naught x raised to the power 6, 6c2 x raised to the power 4, x cube minus 1. Then the next term will become 6c4 x raised to the power 2, x cube minus 1 whole square, and the last one would be 6c6 x raised to the power 0 x cube minus 1 whole cube. This is what we are going to get because we have done this in the last question only. So once you do this, now what they want is the sum of the coefficient of all even degree terms. So now let us open this bracket and get those terms. So this becomes 6c naught x raised to the power 6. The next term, if I open the bracket, will become 62 x raised to the power 7 minus 6c2 x raised to the power 4. The next one becomes 6c4. If I open this bracket, it is going to be nothing but x raised to the power 6 minus 2x cube plus 1. And the last one, if I open, this becomes nothing but x raised to the power 9 minus 1 minus 3x raised to the power 6 plus 3x raised to the power 3. Now, this is what we are getting. And we can simplify it a little bit more. So if I take into consideration, once let's simplify and then take the even powers out. So if I do that, so 6c2 x raised to the power 7 will come, then 6c2 x raised to the power 4 is there. Then the next will become 6c4 x raised to the power 8. Then 2 times 6c4 x raised to the power 5 plus 6c4 x raised to the power 2. And next it will become 6c6 x raised to the power 9 minus 6c6 minus 3 6c6 x raised to the power 6 and so on. So now what you can do is, so on what we can write the last term also. If I write the last term, it comes out to be plus 3 6c6 x raised to the power 3. So now what we want is only the terms having coefficients of the term having even powers. So that are these terms. This one will have to consider, this one, this one, this one. These are the terms that we need to consider. So if I write the coefficient, it is going to be nothing but 2 times 6e naught minus 6e2 plus 6e4 plus 6e4 minus 6e6 and 3 times 6e6. This is what we need to consider. And if I find the sum, I should get my answer. So 6e naught becomes 1. 6e2 we can simplify and figure out. So 6e2 if I simplify, so it is 6 into 5 by 2. So this becomes nothing but 15. So this next term can be written as minus 15. This will become plus 15. 15 minus 1 minus 3. So you can see 115 gets cancelled out. 1 will also get cancelled out. So what we have is nothing but 2 into 12, that is nothing but 24, which becomes our answer. Again, similar kind of question based on substitution. So what you can do here is, if I write the expansion, before writing the expansion, if I do some general manipulation, it can be written as 2x raised to the power 4 plus 3 by x raised to the power 10. And if I simplify, this is 2x raised to the power 4 plus 3 raised to the power 10 by x raised to the power 10. Now let us see that the question is asking sum of the coefficient of all positive even powers of x. See, now if I write a general term out of the numerator, it is 10cr 2x raised to the power 4 raised to the power 10 minus r plus 3 raised to the power into 3 raised to the power. Once you write this down, you will understand that since there is an x raised to the power 4 here, all the powers are going to be even only. Moreover, it is an idea of positive even powers that is more important. Because see, what you have in the denominator is x raised to the power n, so it will get divided by every term. So what we want is, now after this division, the power of x should remain positive. It is obviously even. Only thing that we need to check is it is positive or not. If I simplify this one, it will become 10cr into 2 raised to the power 10 minus r, 3 raised to the power r, and x raised to the power 40, and this was nothing but 10. So if I subtract, this will become nothing but 30 minus 4r after simplification. So our job in this question is very simple. Once you have written it down, you check now the power of x. If I check the power of x, it is 30 minus 4r. This needs to be greater than 0 because they are talking about positive powers. So if I simplify this, then r should be smaller than 15 by 2. That is nothing but 7.5. So the permissible values of r, if I want to write them down from here, are nothing but 0, 1, 2 up till 7. What I can do is I can find the sum of all the coefficients. So method is very simple. Sum of all coefficients. Okay. And you subtract the coefficient of 8th, 9th and 10th term. This is what we will do in order to get to the answer. Now how to get this first part and how to get the second part. So the first part is quite simple. You have already been given an expansion. Let us first try and do the first part. If I want to find this, it is very simple. You write the expansion. And we know it is going to be a naught plus some power of x like this. All the terms will be there till the last one, that is a10 into some power of x. In order to find the sum of coefficients, what you can simply do is you can substitute x equal to 1, and that is what we have been doing so far. If I do so, this becomes 2 plus 3 raised to the power 10. So you will get a naught plus a1 plus a2, a8, a9 and a10. This is what we have got. So in the next part, what we need to do is, in order to find the value of a0 plus a1 up till a7, we can subtract from this 5 raised to the power 10 the coefficient of 8th, 9th and 10th term. So if you do that, you will get your answer. So 8 would be nothing but 10c8 into 2 square into 3 raised to the power 8. This is nothing but 10c9 into 2 into 3 raised to the power 9, and the last one would be nothing but 10c10 3 raised to the power 10. Now if I simplify the last part, because that is what has been asked. So what has been asked is, if I take 3 raised to the power 9 common from here, what will be the answer? So before taking common, let us simplify and then see what we will get. So 10c8 is 10 into 9 by 2 into 2 square into 3 raised to the power 8. This term can be written as nothing but 10 into 2 into 3 raised to the power 9, and the last is nothing but 3 raised to the power 10. So what we can do is, we can just take 3 raised to the power 9 common from all the terms, and what we are getting from the first is nothing but 10 into 3 into 2. From the next one it is 10 into 2. From the last one is plus, there is 3. And if you sum up, this is what is given as beta in the question. So if I go back to the question, it was nothing but beta that was given and asked. So if I want to find this value of beta, it comes out to be 83. Now this next question is based on a very simple result. What they are asking is, if we have 1 plus x raised to the power 99, what is the sum? And this is the first part, the sum of the odd powers of x. So we know this result. This comes out to be the sum of odd powers. Coefficient is given as k in the question and would be equal to 2 raised to the power 98. You already know this result. Once we know this, the second part is to find the middle term. So the middle term in 2 plus 1 by root 2, and this we did earlier as well. Since your power is even, there is only going to be one middle term, and that is going to be 200 c100 into 2 raised to the power 100 into 1 by root 2 raised to the power 100. And this is nothing but a in the question. So if I write the value of it, comes out to be 200 c100 into 2 raised to the power 50. Now what they want is to solve this expression. if I take this one, what they want us to solve is 200C99 into k, that is nothing but 2 raised to the power 98, divide by a, that is 200C100 into 2 raised to the power 50. Now if I simplify it, is very simple, because here we are getting our standard formula NCR minus 1 by NCR minus 1. It is written in the reverse order. So the result was n minus r plus 1 by r. If I apply it here, my n is 200, r is 100 plus 1 by 100. And this will become 2 raised to the power 48. And if I further simplify, this can be written as 25 into 2 square, and the bottom becomes 101 into 2 raised to the power 48. And further if I simplify, it becomes 25 into 2 raised to the power 50 by 101. If I compare this with the statement that was given, 2 raised to the power n, m by n, and what we can understand from here is the value of L comes out to be 50 and the value of n comes out to be 10. If I compare my option, my A option becomes or comes out to be true. Now let us look into this last category of problem, that is nothing but I plus F category problem. Now we are going to do three very specific things. When I am going to demonstrate what is the exact problem using an example. In the second part, I am going to give a shortcut to observe and solve all such problems. And third, we are going to see what kind of previous year questions has been asked on this idea. So let us systematically start with it. So let us first demonstrate or understand the problem. So see, let us say that you have been given 2 plus root 2 raised to the power 100. And what they're saying is it is equal to I plus F. What does that mean is, if you simplify this, this is 3.414. 2 plus 1.414 is 3.414. So question is very simple. If you actually simplify it, there will be some irrational 414, irrational part into it. So if you simplify this, 3.414 something something raised to the power 100. What will be the nature of integral part that they want us to tell, whether it is even or odd? So now this we have a technique or a trick to tell. Let us see how. So what we will do is, we have taken this 2 plus root 2 and we will write its binomial expansion. So if I write its binomial expansion, this is how it is going to look like. 100C0 2 raised to the power 100. Then the next term would be 100C1 2 raised to the power 99 root 2, so on and so forth. Now I am considering another kind of expansion, 2 minus root 2 raised to the power 100. And let us call this as capital F. And if I write this expansion, it is 100C0 2 raised to the power 100 minus 100C1 2 raised to the power 99 into root 2, so on and so forth. So this is my first step. My first step is to take this F. See, now if you look into 2 minus root 2, 2 minus root 2, that is 1.414 if I write, it is a quantity which is 0.5 something something something. And if I raise it to a power 100, this number will become even more smaller. And you can see that it will be something like 0 point something. So you can see from here that F is a quantity that lies between 0 and 1. Got it? So we have been able to observe where F lies based on the values that are given to us. Now once this is given to us, in the second step what we are going to do is, our idea would be to remove or eliminate this irrational term. In order to do that, what I can do is I can take my first equation, that is I plus F, and add my second equation, that is F into it. And if I do so, you can see that you will get 2 times 100C0 2 raised to the power 100. Then 100C2 2 raised to the power 98 into 2 square, root 2 whole square, that will become 2. So on and so forth. And you can see that the irrational powers are now being eliminated. So what we are getting is the value of this term that we have written is nothing but 2 times integer. Or in other words, an even integer or an even number. Now once you have written this, something very interesting is happening. See, if I try and observe it, I here is nothing but an integer. Then what we have is an F, that is fractional part. Fractional part when we call, so see 3.7, this would mean 3 is the integer, 0.7 is the fractional part. So fractional part 0.7 will always lie between 0 and 1. So this is always between 0 and 1. And then you have this f that we already wrote earlier and demonstrated that it is between 0 and 1 again. So what is happening here is when we are writing this up, this is coming out to be again an even integer. What does that mean? You see, this is integer, this is integer. Now what is remaining? This middle part also needs to be an integer. Closure law. The sum or the difference of two integers needs to be an integer. So what we can say is here, if I add f plus f, it is coming out to be an integer. So once you observe this, if I actually add f and f here, so f plus capital F will lie between 0 and 2, that is the range. So the only integer between 0 and 2 is nothing but 1. So f plus f is equal to 1. So this is the thing that we have figured out. Now one advantage of doing this is now first kind of inferences that we are going to draw. So the first inference that we can draw from here is, see this part in this expression I plus f is become an integer, 1. So this is 1, I plus 1 is equal to even number. So see, we know that if I plus 1 is an even number, then I needs to be an odd number, because the sum of two odd numbers is an even number. So now what we wanted to comment, we have already commented. One more inference we can draw, that is inference number 2. What is that? See, if I take this I plus f and multiply it with capital F, something very interesting will happen. So this is 2 plus root 2 raised to the power 100. And if I multiply 2 minus root 2 raised to the power 100, what we are going to get is nothing but 2 square minus 2, a square minus b square raised to the power 100. And this is nothing but 2 raised to the power 100. And this is also interesting. Why? Because the same thing that we have written earlier can be rewritten in this form. Why? Because 1 I plus f is fine, but capital F we know from here as well. So this also can be written as 1 minus small. So there are these two things that are usually asked out of this question. Now let us take another example. In this case, what we are taking is root 3 plus 1 raised to the power 101. So I have taken this power to be an odd number. Earlier it was even number. And also the root has come on the first part now. So if I write this expansion, this becomes 101 C0 root 3 raised to the power 101. Then next term becomes 101 C1 root 3 raised to the power 100 into 1. So on and so forth. Now this we were calling it as I plus f in the earlier part. Again we are calling it as I plus f, where f is the fraction part and hence it lies between 0 and 1. If I write f, that is nothing but root 3 minus 1. Like we did earlier, raised to the power 101, I can write the expansion as 101 C0 root 3 raised to the power 101 minus 101 C1 root 3 raised to the power 100 into 1, so on and so forth. See, now what you can observe here is this is our first part, and here also since root 3 is nothing but 1.732, so root 3 minus 1 will become 0.732, and if I raise it to a power 101, this becomes 0.732 raised to the power 101, a number between 0 and 1. Again it will be 0 point something. You can again observe here capital F lies between 0 and 1. Same thing what we observed in the earlier question. So this much is almost same. Now let us move on to the next part or the next step. What we are doing in the next step is here is, see, we want to eliminate the irrational powers. So here the irrational powers are coming in the first term and then third term and so forth. So earlier what we did was we added 1 and 2. Here instead of adding 1 and 2, we are going to subtract. So in this step 2, what we are going to do is we are going to take 1 and subtract 2 from it. So if I do that, what I get is I plus f minus capital F would be equal to nothing but 2 times 101 C1 root 3 raised to the power 100 into 1, so on and so forth. Now you can see that what we are getting here is nothing and even number. This is also exactly same. The only thing that has changed is instead of getting I f plus f, we are getting f minus f. Again, the rules of the game are same. F lies between 0 and 1. capital F also lies between 0 and 1. So if I subtract them, then F minus F will lie between minus 1 and 1. Again, like in the earlier case, this is integer, this part is integer. So F minus F also needs to be an integer. And only integer that it can become is nothing but 0. So F minus capital F becomes equal to 0. So we can imply that F is equal to capital F. So now let us try and write all the inferences. So first inference 1 that we can draw from here. And inference 1 that we can draw from here is, see, I plus F minus capital F was nothing but even. Since F minus F is 0, so I will be even number. So this is my first inference. In the earlier case, if you observe, this was odd. So this has now changed. Now if I want to write inference number 2, what is going to happen? In the inference number 2, what we are saying here is that if I take this I plus F and multiply by F like I did in the earlier question, this will become root 3 plus 1 raised to the power 101 into root 3 minus 1 raised to the power 101. And you can see that still a square minus b square will apply. So it is 3 minus 1 raised to the power 101. And here you can see that it comes out to be nothing but I plus F into capital F is nothing but 2 raised to the power 10. But we also know that F is equal to capital F. So I can write here something very interesting. And that is I plus F. Instead of writing capital F, let us write small f. This is also equal to 2 raised to the power. So now after doing this, you should understand from this inferences, I will give you two very shortcut results. You do not need to do this whole process all the time, but I wanted to give it to you for the sake of explanation. So now what is the logic? See, if we have been given p plus root q kind of an expression raised to the power even number, like we had in the first part. So in that scenario, the value of I comes out to be odd. And another important result that we figured out was F plus capital F is equal to 1. And using this, what we wrote was that I plus F into 1 minus F, this came out to be P square minus Q raised to the power an even number. So I am writing this as 2n in order to paint the picture of an even number. And another scenario that we noted was nothing but when we have root p plus q raised to the power 2n plus 1. So you can see that the root has come onto the first part. Now in this scenario, your I will become even. This is the first thing that we need to know. The second thing is when we solved, f came out to be equal to capital F. The small f and capital F are equal. And from here we also came up with this idea that if we write I plus F and multiply by small f, it is nothing but P minus Q square raised to the power 2n plus 1. Fine. So if you just remember these two small results, chances are that you are going to do well, and without any calculations, you will be able to get the answer. If you look into this question that was asked in 2023 now, this is a very simple question because if you look into the powers, it is odd, this is also odd. So it was opposite. Whenever the power was odd, your I, integral part, and I took the opposite kind of value. So if this is odd, this will become even. In this case also, if it is odd, it will become even. So when they are writing greatest integer functions of the integral part, it should be even. So option C becomes correct. So without even lifting the pen, you can solve this question under 30 seconds. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.